Ya, udah. Iya, Pak. Ladies and gentlemen, the opening ceremony is going to start in 5 minutes. Please be certainly prepared. Thank you. Video nyalain dong. Profil Universitas Mataram. Oh iya.
Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Ali, Ketua Lembaga Penelitian dan Pengabdian kepada Masyarakat Universitas Mataram, atau yang kita kenal sebagai LPPM UNRAM. Ada
University of Mataram was established on October 2nd, 1962. Located at the heart of idyllic island of Lombok, which renowned for its beauty, natural and cultural diversity, make Mataram University poses a great opportunity for knowledge. Becoming internationally competitive research-based university, ignite the passion for Mataram University to continue pioneering intellectuals by creatively applying their knowledge in research and discovery. Nurturing talented youth to become future leaders who eager to pursue the truth based on faith and piety, give Mataram University a firm ground to contribute at its best to the society. In 2018, Mataram University is ready to answer the call with 9 faculties, 58 departments, study programs, postgraduate programs, vocational programs, diploma. Faculty of Economics, Faculty of Animal Husbandry, Faculty of Agriculture, Faculty of Law, Faculty of Teacher Training and Education, Faculty of Engineering, Faculty of Mathematics and Natural Science, Faculty of Medicine, Faculty of Food Technology and Agro-Industry, Study Programs, Communication Studies, International Relations, Sociology. Mataram University mission in optimizing research and discovery, enhanced with facilities and accessibility for the students and researchers, as well as stakeholders with same common goals in supporting education to solve humanity problems, to fulfill our social responsibility. Hand in hand with the society, Mataram University never to choose run alone, We prefer to work together through collaboration and joint cooperation with partners from every corner of the world in exploring knowledge, science, and technology. Mataram University commit to find the best way in increasing society's quality of life. We have tasted the same hard times. We have swallowed the same sour times. We have passed the storm of challenge and stay strong.
Sebagai Sekda Provinsi Nusa Tenggara Barat,
Ketua DPRD Provinsi Nusa Tenggara Barat,
Direktur Jenderal Prasarana dan Sarana Pertanian, Kementerian Pertanian Republik Indonesia.
saya sangat bangga melihat perkembangan Universitas Mataram yang begitu maju.
saya merasa bangga menjadi bagian dari Universitas Mataram.
Dan kami sebagai Ketua DPRD mendorong agar Universitas Mataram sebagai sebuah universitas berbasis riset sesuai dengan visi misinya pada tahun 2025.
Saya yakin Universitas Mataram akan mampu meraih visi dan misinya.
Universitas Mataram sebagai salah satu perguruan tinggi yang mumpuni untuk mempersiapkan kader-kader penerus.
Assalamualaikum warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya, Salam Kebajikan. We're delighted to welcome you to the 5th International Conference on Science and Technology in the theme of Science and Smart Innovation Technology for New Normal Condition in Industrial Era 4.0, Universitas Mataram, West Nusa Tenggara, Indonesia. The conference is an annual platform that brings scientists from academia and industry together to share and discuss their current research. In addition, this conference is also intended to connect the scientists from the field of technology, health, natural science, agriculture and environment, also socio-technology and education, as well as professionals from various spectrums. Host in the beautiful island Lombok, West Nusa Tenggara, Universitas Mataram has the honor to present you this international conference. This conference is presented by the Committee of Universitas Mataram, which has nurtured the virtuous culture of collective values and the vibrant spirits of Universitas Mataram. It is an honor to me to introduce and welcome Rector of Universitas Mataram, Professor Dr. Lalu Husni SH M.Hum, the Vice Rector for Planning, Cooperation Affairs and Information System of Universitas Mataram, Mr. Yusron Saadi, ST, MSc, PhD, the Head of Research and Community Services Institutions, Mr. Muhammad Ali, SPT, MSc, PhD. The Chairman of the 5th International Conference of Science and Technology, Mr. Buan Ansari, ST, MSc, Engineering, PhD, and also we welcome all the keynote speakers, presenters, and participants of ICST 2020. For a brief moment, we would like to invite you to rise and sing Indonesian anthem, Indonesia Raya. May all we rise. be seated now? Thank you. Ladies and gentlemen, we are now opening the ceremony of ICST 2020 by listening to the conference information and report delivered by Chairman of ICST 2020. Ladies and gentlemen, please welcome Mr. Buan Ansari.
Your Excellencies, Mataram University, all vice rectors of Mataram University, all deans of 9 faculties and director of post-graduate program, head of LPPM, head of LPMKP, head of language center, distinguished keynotes and invited speakers, distinguished participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning. First of all, may Allah subhanahu wa ta'ala give us all salvation and blessing. Thanks to Allah because we are still given health favor to join this spiritual conference. Secondly, do not forget salawat and greeting always pour out to our Prophet Muhammad sallallahu alaihi wasallam who taught the people goodness. Thirdly, I'd like to thank you for this ceremony and the people in here who gave me an opportunity to speak in front of you all. Well, on behalf of the Organizing Committee, it is our great pleasure and honor to welcome you to the 5th International Conference on Science and Technology, ICST 2020, which we held virtually in Universitas Mataram. This conference is an annual platform that brings scientists from academia, industry together to share and discuss current research in the terms of science and smart innovation technology for new normal conditions in industrial era 4.0. We are very delighted that our conference enabled to attract researchers, scientists, and practitioners from several countries. The keynote speakers, invited speakers, and the participants come from around the world, such as United Kingdom, Iraq, Japan, South Korea, Brunei Darussalam, Malaysia, and Indonesia as a whole. There are 5 keynote speakers, 9 invited speakers, 113 speakers in parallel session. The conference topics in this conference are applied technology, health, natural science, agriculture and environment, and also social technology and education. This conference is organized by Institute for Research and Community Service, Universitas Mataram. The conference is a continuation of this conference series on the science and technology, of which the previous was held annually from 2016 until 2019 in Universitas Mataram, Lombok, West Nusa Tenggara. ICST 2020 aims to provide an environment for researchers to discuss the current state of science and technology in industry, university, and companies. Ladies and gentlemen, we encourage all the conference participants to attend the keynote and invited talks presentation. This valuable and insightful talk can and will guide us to a better understanding of the science and smart innovation technology for new normal conditions. We also encourage for all authors to actively participate in the parallel session. It's relevant with the interest of coverage topic in this conference. I will express my deep gratitude to all authors who submitted the papers to the conference and all participants who assisted in accomplishing the goals of the conference. We hope that you will find this conference interesting and that it will provide you with a further opportunity to share ideas with others. I also would like to express sincere thanks to all committee members, especially organizing committee, for the tremendous teamwork effort in making the event a reality. My sincere gratitude also goes to the Director of Universitas Mataram and Head of Research Institute and Community Service, and for the continuous support throughout the preparation of this successful event. At the end of my speech, I would like to invite Rector of Mataram University, who represented by Vice Rector for Planning, Collaboration, and Implementation, Dr. Yusron Saadi, for giving opening remarks to open this conference officially. I think that's what I want to deliver. I wish you all a very successful virtual conference. Thank you for kind attention. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you to Mr. Buan Ansari. Ladies and gentlemen, we are now going to listen to the opening remark given by Rector of Universitas Mataram, represented by Vice Rector for Planning, Cooperation Affairs, and Information System. Ladies and gentlemen, please welcome Mr. Yusron Saadi.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Distinguished guests, speakers, participants, ladies and gentlemen. I would like to express my warm welcome to the 5th International Conference on Science and Technology, ICST 2020. I am very proud to be here with expert researchers and academia from many countries. And it is truly an honor to be able to deliver my opening remark in this exciting international conference. This conference will provide an excellent opportunity for sharing knowledge in the field of science and smart innovation technology for new normal condition in industrial era 4.0. Today, we experience situation which force us to make an extraordinary adaptation due to the pandemic of COVID-19. The world recognizes that some societies are not fully prepared to adapt to a very unusual condition, leaving them in a big shock, and they have no choice other than maintaining the rhythm of the midst of the current situation. Less capable systems are unexpectedly collapsed, and we are in the process of searching for a new normal. In this situation, the development of science and the application of smart innovation technology are of particularly important. I noticed that the aim of the conference is to provide an environment for researchers to discuss the current state of science and technology in industry, university, and companies. The presence of keynote speakers and invited speakers from various countries really enrich this scientific meeting. It can be expected that there will be an interesting exchange of information, especially in terms of scientific development and other technological innovation. Distinguished guests, speakers, participants, ladies and gentlemen. The Industrial Revolution 4.0, marked by continuous automation of traditional manufacturing and industrial practices using modern smart technology, requires experts in its implementation. The disparity between developed and developing countries means there are considerable gaps to be filled in. Therefore, intense interest from participants who will be presenting papers on science development and research finding on smart innovation technology are clear signal that there will be a positive impact from this conference. It is also expected that the conference will create partnership and alliances between universities, industries, and other organizations, which allow co-sharing information and research and development sources, and also to gather the potential of existing knowledge to finally configure the innovation at a larger scale. distinguished guests, speakers, participants, ladies and gentlemen. We have to take this exciting conference forward to make it beneficial in the development of our society. I do believe this event will generate discussion which can be transferred into real works, as in this modern era, there is a strong emphasis on putting theory into practice. I would like to express my sincere thanks and appreciation to the organizers of the conference, keynote speakers, and invited speakers, and also to the sponsors who contribute to this event. To all participants who have joined from different countries, I would like to extend my very warm welcome to this conference. I wish you all have a productive and fruitful discussion. Finally, in the name of Allah, the most gracious and the most merciful, I declare that the 5th International Conference on Science and Technology, ICST 2020, is formally open. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Yusron Saadi. Ladies and gentlemen, now we would like to invite you all to praying together. Prayer will be guided by Dr. Rernat Kosim. To Mr. Kosim, the conference is yours.
Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Nice to meet you. Please allow me speak and to pray in Indonesia language. Bapak, Ibu hadirin sekalian tamu undangan, peserta webinar International Conference on Science and Technology yang kelima di tahun 2020. Mari hadirin sebagai anggota masyarakat yang percaya pada Tuhan Yang Maha Esa, maka sebelum acara dilanjutkan pada kegiatan presentasi seminar yang telah dibuka barusan, ada baiknya kita memohon kepada Yang Maha Kuasa agar mendapatkan keriduan dan perlindungannya selama kegiatan ini berlangsung. Bagi yang bukan beragama Islam, dipersilahkan berdoa dalam hati sesuai dengan keyakinan masing-masing. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. Assalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi wa sahbihi ajmain. Ya Allah, abtahli abwaba rahmatik warjukni ridoka wa taqwaka wa sahirli halqaka bisarayani lutfika. Ya Allah, kami berkumpul dan bersyukur padamu atas segala karunia yang telah Engkau limpahkan kepada kami. Saat ini kami akan melaksanakan salah satu kegiatan amal kebaikan berupa pelaksanaan webinar International Conference of Science and Technology yang kelima dan dilaksanakan di Universitas Mataram. Kami memohon kepadamu agar Engkau lancarkan segala urusan dan berikan kesehatan sehubungan menjalarnya wabah COVID-19 ini. Kami berikhtiar untuk menjaga kesehatan, namun Engkau jualah yang menentukan dan yang mempunyai keputusan. Allahumma afini fi jasadi, Allahumma afini fi basari, Allahumma afini fi sam'i, Allahumma afini fi qalbi. Rabbana atina min ladunka rahmah, wa hayyi' lana min amrina rasada, wa hayyi' lana min amrina rasada, wa hayyi lana min amrina rasada. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Subhanaka rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Thank you, ladies and gentlemen. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you to Mr. Qasim. Ladies and gentlemen, before we're going to our main agenda, we would like to invite you all to take photo session for documentations. All the audience, please kindly show your video. Thank you. Please, to all the audience, to on your videos. Okay, for the audience to the first screen page, please give your best smile on 1, 2, 3. Thank you. The audience on the second page, please kindly give your best smile again. 1, 2, and 3. Okay. Next. To the audience on the third page on the screen, please give me your best smile on 1, 2, and 3. Okay, next, for the audience on the fourth page on the screen, please give me your best smile on 1, 2, and 3. Okay, thank you. And for the last page, to the audience on the screen, please give me your best smile again on 1, 2, and 3. Okay, thank you all to the audience for your cooperation to show your video on the camera. Okay, ladies and gentlemen, we are now continuing our meeting to the next agenda, that is to hear the first keynote speeches, which will be delivered by Professor Dr. Takaumi Arai from University of Brunei Darussalam and Dr. Muhammad Lutfi Firdaus from Universitas Bengkulu. The keynote speech will be moderated by Chairperson Dr. Renat L. Rudiateli Savalas, SSI, MSI. To Mr. Rudiateli, the moment is yours.
Udah spotlight. Dan
Okay, thank you. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahi rabbil alamin wassalatu wassalamu ala asyrafil anbiya wal mursalin. It's a great privilege for me to lead the first session in the 5th International Conference on Science and Technology 2020, University of Mataram. In the first session, we have two keynote speakers. First is Professor Dr. Takalmi Arai from Brunei Darussalam University, and the second one is Dr. Muhammad Lutfi Firdaus from Bengkulu University. Each keynote speaker will present their research within around 30 minutes, and after the two keynote speakers have delivered their speech, we will have question and answer session for around 10 to 15 minutes, even on the time left, and the first session is scheduled until 10:20. Well, now I would like to introduce you our first keynote speaker, Professor Dr. Takalmi Arai. Professor Arai obtained his first degree in the Department of Fisheries, Science and Technology, Tokyo University of Fisheries. And he obtained his master's degree in the same university, and later he got his PhD in agriculture in the University of Tokyo. He has a lot of experiences. After obtaining his PhD, he was an assistant professor at Ocean Research Institute, the University of Tokyo from 2000 to 2006. Then he occupied an associate professorship at the institute, Ocean Research Institute, the University of Tokyo. Later on, he managed to University Putra Malaysia in Malaysia. Okay, it's already 10 years. He lived in Southeast Asia, in our neighbor country, Malaysia. He was head of Marine Database and South China Sea References Repository Center, University of Terengganu from 2013 to 2015. And he obtained his professorship at the Institute of Oceanography and Environment, University Malaysia Terengganu. He currently professor at Faculty of Science, University of Brunei Darussalam. He also member of Senate of University Brunei Darussalam, and he also an adjunct professor at the Faculty of Fisheries and Marine, Universitas Airlangga from 2000. His main research is on fisheries, and as far as I understood, he has done a lot of work on eel. What is it about? He will deliver it later on. He published more than 119 peer-reviewed journal articles in respective journals. Well, now please welcome Professor Takalmi Arai.
I have already sent my video, so can you use my video, or I don't know how I can start my video, or by myself, or you can start.
From us.
I don't know, because I have already sent the video file, so how I can proceed? live presentation. So I need to share the PowerPoint or video file. So I don't know because which one can you suggest or Selamat pagi semua. A very good morning, everyone. My name is Takao Hirai from Brunei Darussalam. Today my topic is diverse migration and habitat use of tropical angular species of genus Anguilla. This is a life history of Anguilla. This species are recognized as catadromous fish. It means that the Anguilla spawn in the open ocean, then leftocephals larvae are transported by oceanic current, then after metamorphosis into the grass seal,
Okay, Professor Takaomi, we have already. Okay, can we hear? Can we see you? Okay, we have already got your video, and we will air the video that you've sent to us. But we would also like to see you. So please turn your video on as well.
so it means that I present current using PowerPoint or how I proceed my presentation.
Okay, would it be possible for you to share screen and present your PPT?
Oh, okay, PowerPoint. So it means that I verbally deliver my presentation, right?
That would be nice. Thank you, Professor Arai.
Okay. So, how to... Okay, so wait one moment. This one. Share screen. So I share the screen now. So this one. I share screen. This one. Can you see my PowerPoint?
Yes, it works. Yeah.
Can you see it?
Yes.
Okay. So I start by myself.
Please.
Okay. So I start. A very good morning. My name is Takaomi Arai from Brunei Darussalam. Today's my topic is diverse migration and also habitat use of tropical ungulate eels of genus Anguilla. This is a life history of Anguilla. Anguilla is recognized as a catadromous eel, means that eel migrate from open ocean to fresh water. At first, eel are spawned in the eggs in the open ocean. Then the leptocephalus, the larvae, are transported by oceanic currents.
Then after metamorphosis into the grass eel, a juvenile, this grass eel migrate into the coastal habitat. Then after growing up, Elba yellow eel, depending on the species, this eel metamorphoses again into the matured eel we call the silver eel. Then after maturation, they are going back to the open ocean for spawning and die. Eel is seminiparous. They lay egg once in their life. This is a global distribution of ungulate eels. I highlight the blue line for the distribution range. As you can see, we can find the eel almost in the worldwide. Of course, we cannot find any eel in the South America and also west part of African continent and so on. But as you can see, we can find almost eel. And also, I highlight the orange color. I mean that these eel are distributed in tropical waters. Then this greenish color I highlight, we normally call the temperate eel, which are distributed in the temperate region. So far, we can find the 19 species, subspecies of ungulate eel distributed almost worldwide. Then 13 species are found in the tropical region. So majority of the eel are distributed in the tropical region. Then furthermore, 7 species, more than 50% of eel we can find in Indonesia and also Malaysian region. It means that this area is a hotspot in terms of ungulate eel distribution. Then based on the phylogenetic analysis, Angina boronensis and also Angina mozambica are recognized as a basal species. But it is still debating. The next is more detail about the diversity of ungulate eel in the world. I just want to highlight, as you can see, the Asian region, especially Southeast Asia, we can find many majority of eel. It means that another reason the eel is originated in this country, not in the region. So studying ecology and biology of tropical ungulate eels can provide some hint to understand the nature of primitive form of ungulate eels and also how these eels are distributed and also dispersed in the world. This is a life history integrated, what kind of impact affected for the life history. Unfortunately, all stages are subjected, either natural or anthropogenic or both impacts during their life, such as overfishing, habitat degradation, pollution, parasite infection, and also climate change. Especially during the oceanic life history, during larvae or juvenile stage, these eels are subjected by global climate change. Then after recruitment, because grass eel are high commodity, then very high pressure for the fishing and also over exploitation. Then currently coastal development, also river improvement quite coastal development and river improvement are quite developed in the many countries. So they lost the habitat. It means that habitat degradation. And also adult eel, both yellow eel and also silver eel also are facing on the fishing pressure. And also parasite infect affect the, how to say, the mortality rate. It means that all life history are affected by the natural and also anthropogenic impact. Then this is a global capture. What I can show is this is most of the temperate species, because unfortunately we don't have sufficient data to discuss the global capture in tropical species. But what I want to highlight is As you can see, this blue, green, blue, and also orange color is a Japanese eel, and also a European eel, and also other species. But what I want to say is, after 1970s, all species are steeply declined for the global capture due to the natural and anthropogenic, especially for the overexploitation. Then this is very few data, but we can see some trend in juvenile stocks in Indonesia. This is Java Island and also Sulawesi Island, compared to 2000, 2010, and also 1990 to 2009 in Sulawesi Island. Because Indonesia also the many effort to recover the stock of Anguillid eel in Indonesian waters. However, we can see decreasing the stock of Anguillid eel in Poso and also Java Island quite steep during the 10 years and also 20 years. However, as I mentioned, it's quite difficult to estimate a long-term fluctuation pattern because so far we have little information available, the varied stock data, and also biology and also ecology of tropical eels. This is some information of spawning ground of tropical eel. Unfortunately, compared to the temperate species, there are few investigations carried out at this moment. But this is some valid information of the spawning ground. In general, temperate eel, the spawning ground is quite far, more than 1,000 kilometers from the spawning ground to their inland habitat. However, as you can see, Anguilla cerevisiensis and Anguilla bolonensis, the spawning ground just next to their growth habitat, it will be less than 100 kilometers. And also another spawning ground you can see in the Tomini Bay, near the central Sulawesi, was very close. And also in Java, this is still debating, but this Anguilla bicolor, the spawning ground, also very close to the Sumatra island of Mentawai Trench. So these characteristics are totally different from that of temperate species. Then this is quite old data because, as I mentioned, we don't have good data to evaluate a recruitment pattern. This is a fluctuation grass recruitment into the North Sulawesi Island from 1997 to 1999. When I was a PhD student, as you can see, we can find a grass eel every month. This recruitment pattern also quite different of that of temperate eel. Temperate eel only migrate in the half year, 6 months, during the winter time, early fall to the middle of winter. However, we can find the grass eel. We can catch grass eel every month, but interestingly, the total number of catch, because this is quantitative analysis, so we can directly compare the data. 1997, 1998. 1997, the recruitment is quite high. However, 1998, the recruitment steeply declined, more than 10,000 specimens to 1,000 specimens. Then 99 gradually recovered. What is happening is one of the reasons is El Nino, because as I mentioned, during the oceanic life history, atmospheric and also ocean change impact for their mortality rate and also transportation route. Then there were El Nino in 1997 and 1998. So it might affect on the larval mortality and also grass eel transportation. Then this is another study of the maturation and spawning ecology, because we know that we found that grass eel are recruited monthly. However, we don't know the spawning ecology. So we conducted this study, reproductive ecology, in the Peninsula Malaysia and also Java Island. using histological analysis. Then today I highlight only for the Anguilla bicolor, because Anguilla bengalensis, we did not find many sample. But what I want to highlight is we could find a stage 5 and stage 4 is a fully matured stage for almost every month. It means that we found that year-round spawning in the open ocean occurred tropical eel. And also this characteristic is also totally different from that of temperate eel. Temperate eel going to ocean for spawning during a half year. So it means a half year spawning induce a half year recruitment. But in tropical eel, year-round spawning induce year-round recruitment. And also another benefit for the tropical eel is to facilitate mate between adult in the different year class, otherwise a cohort, or different habitat, because they can meet for male and female at the spawning ground anytime, so they can easy to mate, and also they can sustain and also maintain their population. So back to the life history of Anguillid eel. As I mentioned, Anguilla is a catadromous species, overall diadromous species. Salmon also include the diadromous species. So, but recent study found that not all eel are necessarily enter the freshwater environment based on the Otoliths microstructure and sorry, Otoliths microchemistry. Some eel just stay in the marine water without freshwater life history. Other eels, they migrate into the freshwater, but during their life, they move to the marine water, otherwise estuarine water. Actually, very complicated. So far we have found that all temperate species show the quite diverse migratory pattern. However, there are a few studies done for the tropical eels. That is why we try to reconstruct the migratory history using a fish otoliths. I just briefly explain. As you may know, the fish otoliths is a very powerful tool to determine the age. As you can see, there are some rings. Then we can determine the age, how old the eel. But not only age determination, because otoliths is made by the calcium carbonate, so many minerals are also incorporated. So we saw that when we look at the strontium, because strontium level in the marine water is almost constant if we go to the open ocean, almost 8 ppm. However, in the freshwater environment, the strontium concentration is almost zero. That is why, based on these characteristics, we can reconstruct the migratory history using this X-ray microprobe analyzer, because we don't need to dissolve the otoliths. We can determine the strontium along the life history transect. So then we can reconstruct migratory history from hatching until die or eel captured. Then if the fish stay in the fresh water, the strontium level is quite low. But after fish migrate into the ocean or estuary, the strontium level is sharply increased. Then after back to the river for spawning, then strontium level is low. So based on characteristic, we reconstruct a migratory history of tropical reef. This picture is an individual Anguilla bicolor collected in the Cilacap, Java Island. As you can see, all eel have a red spot in the central region because eel are spawned in the open ocean. In the ocean, the strontium level is high. But this sample, this specimen, after recruitment, this is a typical migratory pattern. This eel perpetually permanently stay in the freshwater environment without any estuarine and also marine life history. However, all eel were collected in the same environment, but this eel, after certain years, 1 or 2 years stay in the fresh water, but they move to brackish water. This specimen as well. And also this specimen, without no freshwater life, they permanently stay in the estuary or marine water. And also this specimen move various environment during their life. So we found that diverse migratory history have been found in tropical eel, not only a temperate species. So this is another our study using Anguilla marmorata is another. This species is the widest distribution among all Anguillid species. We collected eel from Indonesia, Vietnam, and also Japan. Then I saw all data. Then we found a typical freshwater migratory pattern, but as you can see, this is a quite high level or strontium level, is marine resident, and also this specimen change their habitat from freshwater to marine. So it means that not only Anguilla bicara, Anguilla marmorata also showed diverse migratory history. It means that we haven't yet studied all species, but in tropical species, there are also quite a diverse migratory history. So if we catch eel, some environment, we could not estimate where the eel come from. That is why we need to study otolith microchemistry to understand the life history. So this is another study, the field survey for diversity distribution and also habitat use. We conducted in Peninsula Malaysia. Actually, we try to collect the eel from whole peninsula, but we only found the eel northwest peninsula area. Then this area, this region, Anguilla bicara is majority, the dominant, almost 90%. Then next is Anguilla bengalensis, 12%. Then this is Anguilla marmorata. This species composition is quite similar to that of Sumatra Island because those eel are transported by the similar oceanic current. That is quite similar. Then we highlight the Penang Island. Then we collected river along the riverside. Then we found different distribution pattern. In general, this black is Anguilla bicara. For example, this is same river. So normally we can find, we could find Anguilla bicara in the river downstream to the midstream. However, Anguilla bengalensis, this white color, we normally found Anguilla bengalensis in midstream to upstream. So it means that there are some habitat segregation between the two species. For example, Anguilla bengalensis prefer to stay the cooler upstream water and also high elevation area. Then we found the habitat preference is coming from species interaction and also interspecies variation integrated in the environmental condition, in the local environmental condition. However, we don't know. We obviously found that habitat segregation, but this Anguilla bicara is really stay in the same environment or not. Or even Anguilla bengalensis we collected in upstream, but whether Anguilla bengalensis permanently stay in the upstream or they move other environment or not, we don't know. That is why we also apply the otolith microchemistry. This paper we have just published this year. Then the top is Anguilla bengalensis. The others are Anguilla bicara. So after otolith microchemistry, after recruitment to the coastal, Anguilla bengalensis permanently stay in the freshwater because strontium level is very low. So we did not find any habitat shift in Anguilla bengalensis. However, Anguilla bicara prefer to live more downstream to midstream with tidal influence because, as you can see, of course, some stay in fresh water, but others they quite higher level of strontium level, and also we could find habitat shift from fresh water to marine water or marine water to fresh water. So very complicated. So overall, based on the Otolis microchemistry and also the field survey, Anguilla bengalensis prefer to live mainly in the upstream to midstream, then lower temperature and also higher elevation, the very consistent with the field survey. Then their habitat use, migratory history, and habitat distribution indicate the habitat segregation definitely occurred between two species, leading to different habitat preference in the tropical river system. So based on this result, when we look at the conservation and also management, for example, this between the Anguilla bicara and Anguilla bengalensis, Anguilla bengalensis stay in the river upstream. It means that their habitat is very limited. And also, if we develop, for example, the habitat reclamation and also some developing, then Anguilla bengalensis and also bengalensis are more vulnerable for the anthropogenic impact. So when we look at conservation management, we need to consider by species because the habitat distribution and also habitat preference are different depending on the species. So thank you very much. That is my talk.
Okay, thank you, Professor Arai, for a very nice presentation. Before we go to the question and answer, we'll have Dr. Muhammad Lutfi Firdaus, our second keynote speakers. Yeah, I will shortly introduce you, Dr. Lutfi Firdaus, but we would like to ask Professor Arai to stay with us until the question and answer session.
Okay, sure, no problem.
Okay, thank you. Well, our second keynote speaker is Dr. Lutfi Firdaus. He obtained his first degree in chemistry at Pajajaran University in Bandung, and he managed to get his master's degree in environmental engineering, Bandung Institute of Technology, and later he got his PhD in Kyoto University in the area of environmental chemistry. He has several postdoc experiences, such as in Tokyo University in Japan 2030, and in 2016 he also got postdoctoral research in ICST, Italy, and next year he also had postdoctoral study in MIT, USA, and lastly in Imperial College London in UK in 2018. He published numerous work in analytical chemistry with environmental relationship, and I just take a look at he published around 30 peer-reviewed articles in respective journals, and today he will talk about DIC, digital image colorimetry for chemical compounds analysis. Now, please welcome Dr. Muhammad Lutfi Firdaus. Okay. The conference is yours, please.
Okay, thanks moderator for the nice introduction. Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, it is my great pleasure to be here to meet all of you. First of all, I'd like to thank the committee led by Dr. Buan Ansari for inviting me as one of speaker in the ICST 2020 conference. My name is Lutfi. I am working in environmental chemistry research group, University of Bengkulu. So today I would like to share our recent research result on the development of digital image colorimetry for the chemical compounds analysis. First, introduction. As we all know, chemistry is a central science. Here I show the relationship between analytical chemistry and the other sciences. For example, with medicine that consists of clinical chemistry, medicinal chemistry, pharmacy, toxicology, all of them need the analytical chemist to determine chemical compounds in their samples. So it is also true for other sciences such as material science, social science, agriculture, environmental sciences, geology, biology, chemistry itself, physics, and engineering. All of discipline is connected to some extent, especially when they need to determine the chemicals in the samples. Current methods or instruments for metal analysis include ICP mass or mass spectroscopy, ICP OES, AES, AES, and X-ray diffraction. The accuracy and precision are excellent for these instruments. By using ICP mass, for example, we can also measure several elements simultaneously in a very short time. However, the instrument itself are very complicated as shown in this slide. We need a laborious and time-consuming sample preparation and so on. In addition, instrumental analysis need abundant argon gas as the carrier for samples, stable electricity, special room with a good air conditioner, etc. So it is also true for organic compounds analysis. Thus, besides their advantages among other methods, they also possess several drawbacks. Here, I list some disadvantages of modern instruments, such as high capital costs, more operator experience needed, high running and maintenance costs, matrix interferences, isobaric interferences, instrumental drift, bulk, and not portable. So ICP mass, as shown in this picture, is not practical for Indonesia, and we need other alternatives. Colorimetry is one of them that I choose and developed in the lab. In addition, we have modified the traditional colorimetry to digital image colorimetry, or DIC. The DIC is an emerging method that currently used in various fields and disciplines. As we may know, colorimetry is a part of spectrophotometry. For heavy metals or inorganic compounds, we have to synthesize a complex with a ligand to make it colored, such as hexaaquo-iron 3 ion here, that has a yellow to orange color. For organics, the one that has a chromophore and auxochrome will get colored as well, such as dyes, pigments, chlorophyll, and so on. So besides these two mechanisms, recently scientists developed a novel metals nanoparticle that also colored. Silver nanoparticles have yellow to brown color, while gold nanoparticles have red to purple color, depending on the size of nanoparticles itself. The reason for this nanoparticles color is not due to complex formation, nor the chromophore auxochrome groups. This is because the extremely small size of nanoparticles itself, which is within 10 to 100 nanometers. So even compared to the visible wavelength from 400 to 700 nanometers, nanoparticles is still smaller. This results in a phenomenon called SPR, or surface plasmon resonance. The incoming electric field from visible electromagnetic wave will polarize the electrons of nanoparticles that in turn will easily promote it to the excited state, and it will finally produce color when electrons turn back to the ground state. Next is the research method. In this presentation, I will focus on the green synthesis of silver nanoparticles and its application to detect mercury ion by using digital image colorimetry. Silver nanoparticles can be made from silver nitrate as precursor by using aqueous fluid extract as bioreductor and sunlight irradiation as an energy source. We can easily produce a yellowish brown silver nanoparticles that with mercury ion will turn the color back to the colorless. Besides using a UV fish spectrophotometer, we also use digital camera or smartphone to record the digital image, as shown in this figure. Next is results and discussion. The left side figure shows the time-dependent UV fish spectra of silver nanoparticles formation at room temperature and without sunlight irradiation. The x-axis is for visible wavelength from 300 to 700 nanometers, while the y-axis is for absorbance. Pure water, silver nitrate, and fruit extract have no peak absorbance due to their colorless appearance. We can see that it needs at least 7 days to synthesize silver nanoparticles without sunlight. In contrast, on the right side figure, we can see that only within 30 minutes, silver nanoparticles can be produced with the help of sunlight. So we use sunlight as a green energy source throughout the rest of the experiment. Okay, this slide shows the proposed reaction mechanism, why sunlight can speed up the silver nanoparticles formation. Ascorbic acid is a bioreductor extracted from the fruit that oxidized by the silver nitrate to produce ketone functional groups. Upper scheme is for reaction without sunlight, and lower scheme is for those with sunlight that pass through a radical reaction. Thus, the reaction with sunlight assistance is much faster due to radical mechanism. The resulted silver nanoparticle or silver with a zero oxidation number has a yellowish brown color. Yes, selectivity test is compulsory for the development of novel analytical method. We can see here that mercury gives the highest delta absorbance compared to the other metals due to the loss of silver nanoparticles color. In contrast, the other metals give no significant delta absorbance. So from this slide, we conclude that the system is selective and can be used further to analyze the dissolved mercury. This figure shows the digital image of silver nanoparticle solution, demonstrating the loss of color with increasing concentration of mercury ions in the upper scheme, and UV visible spectra of silver nanoparticle colloidal solution after addition of various concentration of mercury ions in the lower scheme. Successive addition of mercury decrease the peak absorbance with a significant blue shift. So the zero oxidation number of silver nanoparticles is oxidized to silver plus ion that has no color. From this experiment, we can draw the calibration curve that has an excellent linearity. This figure shows the illustration of mercury detection using silver nanoparticles. Initially, we synthesize the silver nanoparticles, and then silver nitrate is a colorless solution with +1 of silver oxidation number. The reduction results in a zero oxidation number of silver, which is a colloidal silver nanoparticles that also has a yellowish brown color. If the sample contains mercury, the brown colloidal silver 0 will turn back to colorless silver +1 through a reduction oxidation reaction. This color change is utilized as the basis for colorimetric detection. Next one is a digital image incorporation to the detection system. DIC or digital image colorimetry will improve the sensitivity and portability. We use digital camera or smartphone as a detector and the same time as a tool to calculate the analysis. So instruments that we need are Mini Studio to manipulate the lighting, digital camera or smartphone as detector, and MATLAB or ImageJ software to calculate the result. In spectrophotometry, the complementary color is used to absorbance mechanism, while in DIC, actual color is used due to reflectance mechanism. This red, green, blue color system is important in DIC to predict the complementary colors. Okay, next. This slide shows the setup of homemade Mini Studio that we use to detect the ppb level concentration. So our eyes sensitivity is similar to those of spectrophotometry. We cannot differentiate a very low concentration in ppb level of mercury ions. But for ppm level, it is okay. After addition of 150 ppm of mercury, the silver nanoparticle solution turned to colorless due to the redox reaction. In this slide, we can see that spectrophotometry could only detect the concentration in ppm level, while in DIC, we can detect up to ppb level, comparable to those of ICP mass. In spectrophotometry, the linearity is poor, which is only 0.79, while in DIC, the linearity is excellent, close to 1.0. This is due to the wider dynamic range of DIC compared to spectrophotometry. The absorbance is only from 0 to 2.0 in spectro, while in DIC, it is much broader, from 0 to 255. Thus, the sensitivity is better for DIC. In the last part of presentation, I'd like to introduce our recent results on the determination of organic compounds, such as glucose and ascorbic acid. We have synthesized a hybrid silver-gold nanoparticles for this purpose and got promising results as shown in this figure. The red color of nanoparticles changes to blue color when contact with glucose, while those of ascorbic acid is yellow. So using this system, we can analyze both biomolecules simultaneously. The UV phase spectrogram is as follows, while other compounds have lambda maximum at around 520 nanometers, ascorbic acid was blue shift to a shorter wavelength, and glucose was red shift to a longer wavelength. Thus, this system is excellent for qualitative and quantitative analysis of biomolecules, especially for ascorbic acid and glucose. The sensitivity test is conducted by varying the concentration of analyte and build a calibration curve. We can see from these figures that digital image result in a very good linearity with R square equal to 0.99 for blue intensity. From replicate analysis of blank measurements, we can draw the detection limit of the system, which is around micromolar level. In order to improve the portability, we immobilize the nanoparticles onto paper-based analytical device or PAD. In addition, we have built a smartphone apps called the Mercury Detector that can be downloaded from Google Play Store. So by using the system, we can do analysis in a remote area with limited resources, such as an artisanal or traditional gold mining that is abundant in Indonesia. So in summary, it is proven that digital image colorimetry coupled with paper-based sensor and smartphone application can be a good alternative to the instrumental analysis with some advantages such as accurate and precise, selective and sensitive, low cost and portable. Overall, the digital image colorimetry is a green chemistry or chemical method that save a lot of resources compared to ICP mass or other instrumental analysis. Okay, that's all my presentation. Thank you very much.
Very much, Dr. Lutfi Firdaus. Now let's give big applause to the two keynote speakers for the first session. Okay, now we would like to welcome questions from audience to both speakers. Is there any question from audience? Okay, while waiting, I have simple question for Professor Arai. For me myself, eel is not so popular. Maybe that's also the case for our colleagues here. Eels are not really popular for me, yeah, and for some of us. But you've shown us a lot of research on eels, even in Indonesia. I would like to know what's the potential to find eels in other parts of Indonesia, such as in Papua and South Maluku. Yeah, because you've shown us you've done some work in South Java and Sumatra, yeah, and Sulawesi as well.
Yeah, so in terms of the research of Papua New Guinea and also other regions, actually there are some local, the researcher has conducted some species diversity and also some DNA barcoding to understand the diversity. However, there are basically there are very few information, and also as far as I know, no information available for example, recruitment pattern, and also life history study in the tropical eel in that region.
Yeah. in your presentation, you have shown us two kind of eels, namely big color, and Bengalerensis. From economic point of view, which one is more promising?
Yeah, that is good question. Actually, definitely Anguilla bicolor, otherwise Anguilla bicolor is a higher commodity because Indonesia had already exported Anguilla bicolor to East Asian country, and also in Java Island, there are many factory or aquaculture farm to culture the Anguilla bicolor for international trading. So definitely Anguilla bicolor is a higher commercial value.
We are lucky to have, as you said, around 90% of big color instead of Bengalerensis, right?
Yes.
Okay. And from one of your slides, I note that in certain time when there was El Nino, the capture of eels was steeply reduced.
Yes.
And as far as you know, this year we have El Nina instead of El Nino. And what can we expect from this current phenomenon?
Yeah, that's also a good point. Actually, both actually ENSO is both El Nino and also La Nina impact. Both ENSO is highly impact for the mortality rate and also the recruitment success for grassy, not only El Nino, but also La Nina also high impact. Because unfortunately, we don't have such kind of data integrate the grassy recruitment and also ENSO or in the tropical yields. However, we have such kind of data of European eel and also Japanese eel. Based on their species, their recruitment pattern is highly influenced by the ENSO.
Will it be?
They
Would you
reduce.
expect to reduce?
Yeah, the steeply declined
Okay.
recruitment. Yes.
Okay. Okay. While waiting for other question from audience, I have now moving to Dr. Lutfi Firdaus. Yeah, there was also a nice presentation because I was also trained as chemist. Dr. Lutfi Firdaus, I mean, yeah. I have one or two questions for Dr. Lutfi Firdaus. You've developed a new method to replace colorimetry method, yeah, and for very precise determination of metals in the environment, you may need to use ICT, MS, and other expensive devices. Now, I was impressed by the finding from your work that you have good linearity curve for the DIC method that you developed. And now the other issue is, what about the acceptance of this kind of data if you want to do some research and publish your work? What about the acceptance of the data generated by using DIC? Or is it merely for analytical journal development of new analytical tool and so on? Okay.
Thank you, Dr. Telly, for your nice question. So actually, yes, we can publish several papers in the high quality impact factor journals, such as the newest one is in MDPI publisher, and it got a very high citation rate. So two of my papers was awarded as a highest cited articles. One in analytical science journal published by Japan Society of Analytical Chemistry, and another one last year I awarded or published in MDPI chemosensors. And then if we search the Google Scholar or Scopus database, we can also found several publication in DIC topic for another field. For example, in food topics for medicine, and also even in marine chemistry itself, they start to use DIC analytical method because it is much simple and also low cost. So I think in future, this kind of topics is very promising, and I will continue to do the research and publish it in a high impact factor journal.
Okay, that will be great, Dr. Lutfi. And I would also like to hear later on, a couple of time after this conference, that you can detect strontium to detect how the concentration of strontium in several areas to detect the yield. Yeah, from Professor Arai's work. Yeah. We have also one question from Dr. Ninyaman Kenchanawati. The question is how to prepare the specimen size to quantify the color change on a material using colorimetry. For example, to detect the color change of concrete surface after a fire. Yeah, Dr. Kenchanawati is mechanical engineering or yes, civil engineering. Yes. Okay.
Okay, thank you for the question, Dr. Nyoman Kenchanawati. Yes, the principle of DIC is the sample or specimen itself have to be colored. So for example, in my case, heavy metals, most of them is not color, do not have a color. So we make it colored by using a ligand and makes a complex. Then we can detect it using colorimetry. So in your sample for specimen, how to prepare the specimen size? Okay, yes, in my case, I usually prepare the solution around 1 to 2 milliliters is enough because I use a spectrophotometer as to test the accuracy of our method. So we compare the DIC or digital image colorimetry to the spectrophotometer using a 2 milliliters sample size, and we place it in a cuvette. So it is a very, very small quantity. I think in your case, you can first extract the analyte of interest from the specimen and then dissolve it in water, pure water. So 2 milliliters is enough.
Okay, thank you. And okay, we're still waiting for a question, but meanwhile, I would also like to know your current research. You are working with biological molecules such as glucose, ascorbic acid, etc., and also uric acid. It will be interesting to hear afterward that the method that you developed can be used as a simple, fast, and cheap tool to detect uric acid, glucose level, etc. Okay.
Yes.
And also, I also noticed that you are from Graduate School of Education, Bengkulu University. It means
yes.
that more or less, it's like I'm assigned at Faculty of Education as well, although I was trained as chemist or biochemist. In the current situation where it is very hard to do experiment work, laboratory course for students, how would you suggest that the method that you developed can be used for students to do experiments in their on home, for example, by downloading the application that you've developed, and is it possible for the students to do the experiment in their home?
Yes. Yes, in this pandemic situation due to COVID-19, we stop all of the offline course and also experiment in the lab. So as a solution for that, we now still doing some experiment, but with a very small students number. So I have around 4 students that I supervise for their thesis, and they do experiment in the lab because only 4 students within the very large lab, so it is still okay. And we still do some protocol for COVID-19's pandemic. So these 4 students, they make some video for experiments using this DIC and how to prepare the samples, how to analyze the result, and did some conclusion. So after that, the video that they made was shared to other students. So the student can still continue their study, especially in this topic, digital image colorimetry, at their own home. So by watching the video that we made in the lab.
Okay. Okay. They then report the video from their work. Was it also possible to use the same applications to for example, to use food coloring agents as sample instead of chemicals, which is
yes,
difficult to find?
Yes, of course. As long as the samples is they have a color, so we can use. For example, we rarely use chemicals. So we use, for example, Fanta or other drinks, beverage that has color, such as Fanta. We have a red and also yellow color. So we use that as a sample to calculate the concentration. First, we made a calibration curve by dilute this Fanta beverage with some pure water, so the color will gradually change, and then we draw a calibration curve with linearity close to 1 if possible, and then we give sample X to the student, and they determine the concentration of the sample. Usually we use a percentage concentration unit. So we can use anything around us, not only chemicals.
Okay, that will be nice as well. Is there any more questions from audience? Okay, if it's not the case, I would like to one last question from Dr. Satyo Saloko from Food Science Faculty of Food Science. I think it's different interpretation between UV spectrophotometry and DIC. What would is the accuracy of DIC better? And he also asked the price.
Okay. Yes, the accuracy is similar between DIC and spectrophotometry and ICP mass, because this spectrophotometer and ICP mass already well known by all of the scientists around the world. So the accuracy is similar. But what is better from the IC is the sensitivity. We can detect a lower concentration of samples using DIC compared to spectrophotometry. Why it is occur? Because in DIC we have a more broad dynamic range. As we know, RGB, red, green colors consist of 0 to 255 value, while in the spectrophotometry absorbance is only 0 to 2.0 absorbance. So the sensitivity is better. How about the price? Yes, in DIC we can use the ubiquitous smartphone. So everybody has smartphone. That is the main tools to use DIC. So we only install the apps. So I already published mercury detector in the Google Play Store. So we can download it and we use it to detect the mercury concentration in some samples. So the price is much cheaper compared to the spectrophotometry because we only use our digital camera or smartphone.
Okay, that will be nice for us to hear this kind of work. And instead of using smartphones, would you? I mean, we would also like to hear something in the market that we can probably use for our laboratory course instead of using smartphone. I mean, in certain case, you may also need special kind of camera instead of smartphone, and we would like to have that kind of product in the market later on. I don't know. Hopefully, yeah. Okay. If there's no more question, I would like to sum our first session up by stating the presentation from Professor Arai. Professor Arai has done a lot of research on eels in the Southeast Asia, in Malaysia, Indonesia, and Brunei, Darussalam, and he notes that there are two kinds of eels in Southeast Asia, namely big color, and Bengalari species. And the life cycle of eels was very complicated, and so that the research to understand how the behavior of eels is a lot of work, as far as I understood. But we'll be happy to hear later on that by understanding the life cycle of eel, we can manage our environment so that to facilitate the growth of eels, so that we can capture more eels in the future. That's from my own perspective, actually. And the second presenter, it was also a nice presentation from Dr. Lutfi Firdaus. He developed the IC, digital image colorimetry, as a substitute for several expensive devices normally used in analytical laboratories. So thank you very much for Professor Takomi Arai from University of Brunei Darussalam, and for Dr. Muhammad Lutfi Firdaus from Bengkulu University. Now let's give big applause for our excellent keynote speakers. Thank you very much.
Thank you.
Passing this session. I hope later on we can share the PowerPoint from Dr. Lutfi and the record of today's presentation from Professor Arai as well. Thank you very much. I'm closing this session by saying Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, thank you very much to Mr. Rudiatali as our moderator for the first session of keynote speeches. Ladies and gentlemen, we are now continuing our meeting to our second keynote speeches, which will be delivered by Associate Professor Ali Sofian, PhD, C Engineering from International Islamic University Malaysia, Associate Professor Dr. Zulkifli Muhammad from UiTM Shah Alam Malaysia, and Professor Dr. M. I. Gede Pasek Sutawijaya from Universitas Mataram. The keynote speech will be moderated by Chairperson Muhammad Samsu Iqbal, STMT, PhD. To Mr. Samsu, the agenda is yours.
Thank you, MC. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang. Good morning, everyone. Thank you very much for participating in this fifth ICST 2020 International Conference on Science and Technology, hosted by the Institute for Research and Community Services, Universitas Mataram. And first of all, I would like to introduce myself. My name is Muhammad Samsu Iqbal. I am the teaching staff at the Department of Electrical Engineering, Universitas Mataram. I did my PhD in electrical engineering from 2011 to 2016. And every day I am the head of Department of Electrical Engineering, Universitas Mataram. Respective participants and also the invited speakers, of course, first of all, I would like to welcome you to come virtually to the Universitas Mataram. As we know that last year we conducted this ICST, the fourth ICST in Mataram, and then a lot of participants come from everywhere around the world to come to join the seminar, the conference, and also enjoy living with us here in Mataram. But I can say fortunately or unfortunately that now we meet on the new platform, the online seminar. In this session, we have three speakers, and I would like to say hello to the speakers. The first of the speaker is Dr. Ali Sofian. Hello, Dr. Ali. Are you already online with us? Assalamualaikum, Dr. Ali Sofian. Waalaikumsalam. He just replied from the chat room. Okay, are you ready to present? Oh, he said that he can't get muted. So please, committee.
Okay, yeah, Alhamdulillah. Thank you.
Hello,
Yes.
Dr. Ali. Assalamualaikum.
Yes. Waalaikumsalam. Can you hear me?
Yes, clearly.
Okay, Alhamdulillah.
Okay, thank you very much. So while you prepare your presentation, I would like to say hello to the second speaker, Dr. Zulkifli Muhammad. Hello, Dr. Zul. Can you hear me, Dr. Zul? Are you online with us? Okay, he said that same problem. So please, committee,
I think now it's okay. I think.
Okay.
Waalaikumsalam.
Waalaikumsalam warahmatullah. How are you?
Alhamdulillah.
Apa kabar?
Alhamdulillah baik, Pak.
Alhamdulillah. So, Dr. Zulkifli, Dr. Ali Sofyan is in Department of Mechatronic Engineering, International Islamic University Malaysia, and Dr. Zulkifli Muhammad is with Faculty of Mechanical Engineering, University Teknologi Mara, and the last speaker is Professor I Gede Pasek Sutawijaya. He is with Department of Informatics, Universitas Mataram. Hello, Dr. Prof. Pasek.
Hello.
Are you with us?
Yes. Can you hear me?
Yes, clearly. Thank you very much.
Okay. Nice to meet you all.
So all participants and also speakers, I would like to inform you that we have around 2 hours from now. So we will divide the time to be 2 sessions. The first is presentation and the second is for discussion. And we allocated around 30 minutes for all speakers to deliberating the presentation, and then the rest of time will be the session for discussion. And for the first speaker, I would like to introduce Dr. Ali Sofyan. Okay, Dr. Ali Sofyan completed his Bachelor of Engineering in Electronics and Information Engineering from University of Huddersfield, England in 1998. And then he also completed his PhD in Electronics Engineering from the same university in 2004. And then Dr. Ali also have the Chartered Engineer from UK Council of Engineering. He got it in 2013. And now Dr. Ali Sofyan is the Associate Professor at the International Islamic University Malaysia. He get it the level of Associate Professor in 2015. And then
2020.
Dr. Ali also a program assessor at University KL, Kedah, from 2016. And then Dr. Ali also the section editor at IIUM Engineering Journal from 2019. And also Dr. Ali handling editor for the Asia region for ARS Tech Journal. This journal is owned by Universitas Muhammadiyah Surakarta. And then Dr. Ali will present his paper on the topic of Industry Revolution 4.0 and its application in non-destructive testing. Dr. Ali already provide the video, for the video of the conference, and then please, Dr. Ali can share the video or directly give the presentation. For Dr. Ali, the time is yours.
Okay, Bismillahirrahmanirrahim. Thank you very much, Mr. Moderator, Dr. Muhammad Samsul Iqbal, for the time given to me. Ya, Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. First of all, I would like to also to thank the committee of this conference, the 5th International Conference on Science and Technology, who has invited me as one of the speakers today. Yeah, I am Ali Sofian, as has been introduced, and I've been working at International Islamic University Malaysia, that is located in Gombak, just outside Kuala Lumpur. Okay, and the topic of my presentation today is related to non-destructive testing and Industry 4.0. Yeah. I've been carrying out research in non-destructive testing in total for around 10 years, yeah, starting from my PhD and then my postdoc, and then also during my work research in IIUM, International Islamic University Malaysia. Yeah, yes, specifically on eddy current NDT, non-destructive testing. However, for this for today's presentation, I chose the title, the topic as non-destructive testing in Industry 4.0, in order it to be more in line to the theme of our conference today, yeah, which is on the new norm, the IO 4.0, and how we science and technology can contribute to this period, yeah, difficult time here. Okay, now let me share my slides with you. Where's the button here? Okay. Yes, can you all see my slide?
Yes, clearly.
Okay, alhamdulillah. Thank you. All right. Okay, this is the agenda of my talk today. I will start with some introduction to non-destructive testing. This is mainly for the benefit of those who have not or who are not familiar with non-destructive testing. Yeah? For me, myself, when I was doing my undergraduate degree with or S1, NDT, I was not familiar with NDT. I started to know about NDT when I started my PhD in University of Huddersfield, because the topic was on eddy current NDT, right? Okay, after that, I will briefly present Industry 4.0, yeah, just for introduction. And also it's beneficial for me as well, so that I can then relate the next section of the agenda, which is on IR 4.0 and NDT. Then I will give some future outlook in the research, especially of NDT equipment. And then before I come to conclusions, I will then briefly present the research that I've been doing so far. Okay, so what is non-destructive testing? Again, this is just a basic introduction for those who are not really familiar with NDT. So this definition shown in the slides is the definition given by American Society of Non-Destructive Testing, or ASNT, that non-destructive testing, or NDT, is the process of inspecting, testing, or evaluating materials, components, or assemblies for discontinuities, yeah, or differences in characteristics, i.e. it can be defects, it can be flaws, yeah, without destroying the serviceability of the part of the system. Yeah. So therefore, after the inspection or the test is completed, the part or the system can still be used. Yeah. On the right-hand side, I put an image of an X-ray image here, just to give us probably a better, more easily to understood. Yeah. In human beings, in for human body, that we have some technology such as X-ray, yeah, and then ultrasonic, yeah, and then we've got MRI as well, yeah? And this allows us to see what's inside our body without actually causing any damage, or any injury to the body or to the skin. Yeah? Or it's, for human body applications, these techniques are called non-invasive. So when we apply the similar technologies to structures, to materials, yeah, these techniques are called non-destructive testing. Yeah? And the bottom right of the slide, this is an example. This is actually one of the research that I've been doing. If you see here, yeah, yes. Yeah, this is a pipe inside, and then you we have an insulation over the pipe. And then over the insulation, we have another layer which called the cladding. Okay. The challenge here is how we can detect the presence of corrosion in the pipe without actually removing or damaging the insulation. So this is a challenge, and this is one good example of the application of non-destructive testing. Okay, in non-destructive testing, there are so many techniques are used, and they all have different principles of physics behind it. And this list is not exhaustive. There are visual, ultrasonic, radiography, eddy current, and so on. And all these techniques are complementary, i.e., they are not none of them are better than the others. However, in one applications, one technique could be the best, the most suitable one. However, when it comes to another application, then we might want to use another different technique. So again, these techniques are complementary, and even many of them are best only for a very specific application. Okay, what are the applications of NDT? It's so versatile, and it is so versatile, it's so widely used in many settings. When we talk about a product life cycle, basically at every stage of the life cycle, NDT is used, from the selection, the evaluation of the raw materials, and then during the production, and then when the production is being used, and then even after the product is no longer used, no longer needed and being recycled, even at that stage, NDT is potentially used, or it has actually been used as well. And then in terms of industrial sectors, it covers so many sectors. Oil and gas, this is could be one of the main applications in Indonesia, for example. And in Malaysia, I had been working with some industrial company as well in doing on oil and gas. Then power generation, transportation, aerospace, automotive manufacturing, and so on. So it covers so many industrial sectors. Okay, it's quite challenging and interesting to do research in NDT equipment, and then because one of the reasons is the NDT market is huge and is growing as well. This comes from a report presented or published by this 6W Research. So in this coming near future, there are some driving factors been listed here, which are the aging buildings, the buildings that get old, and as they get older, they have to be. I mean, here we have people expert from civil engineers. My background is electrical, so I think our colleagues from civil engineering background have better knowledge on this. So when the buildings get old, it needs to be it has more requirement to be tested and evaluated to make sure that the structural integrity is still healthy enough to be used. And there are more stringent safety regulations stipulated by governments all over the world. And then, interestingly, according to the report, there is an increasing demand from our region here, the Asia Pacific. Okay, and then to give some illustration on the market, the global market, this here is specifically on the equipment. We are not talking about the services, for example. The global equipment market will be growing quite rapidly. If you see that at 2019, which is last year, the value was 14 billion US dollars, and then it's expected to be reaching to 30 billion US dollars in 2025. And according to the report, in the coming future, Indonesia is still very potential for NDT market, especially in the electricity production for fossil fuel segment. And this will include inspection of pressurized pipelines, boilers, and exhaust systems. Okay, with the current advancements of NDT technology, actually they are quite advanced already. However, as we know that as human beings, we keep innovating and trying to get a better and better solution. Also, despite the advanced development in NDT, there are still problems that are reported by operators especially. Here it includes the high labor intensity. So we need a lot of people basically to carry out this NDT testing. Shortage of skills and aging workforce. So there are a shortage of operators, people with qualifications in NDT. And aging workforce, I'm not really sure, I don't have the data for Indonesia, but for some countries in Europe, their operators, NDT operators are getting older and close to retirement age. Then complex user interface. If you use the advanced one, the user interface are quite complex, can be quite complex with all the menus, the settings, and so on. And then complicated data interpretation. How do you relate the data that you get from the equipment back to the properties of the material, for example? And then the inspection speed, accuracy, and repeatability, although it has improved, but there's still a report coming from the NDT community that they still need to be improved. And finally, the slow or cumbersome data sharing process. From the equipment, when the data already obtained, how do we then interpret this into useful information? And then how this useful information is then passed on to the, for example, the clients, and then probably to some of NDT experts as well. Okay, so there's a bit of introduction on NDT. Now about fourth industry revolution or industry 4.0. I will try to give a bit of introduction as well. Okay. About back to the history, I think maybe all of you are already familiar with this. So this industry 4.0, or some people call it industry 4.0, has been coined back in 2011. 2011 in Germany. And with this industrial revolution 4.0, it actually, I mean, the history of the development in the, when we talk about industrial revolution, this is mainly referring to the manufacturing industry, And then historically, the first industrial revolution was thought to be happening in the by the end of 19th century. This is when the mechanization was introduced, when we had, or when the steam engines was discovered. And then at the beginning of the 20th century, then we take that the second industrial revolution or industrial revolution 2.0 took place when mass production was made possible, especially with the electrical systems that were innovated at the time. And then towards the end of the 20th century, more specifically on the 60s and 70s, but probably more on the 70s, the third industrial revolution took place. This was triggered by the availability of microprocessors, or digital microprocessors, and what we call PLC, programmable logic controllers. And then with time, people develop internet and so on. And now is the time for the industrial revolution 4.0, which is characterized by internet connectivity, big data analysis, and mainly in artificial intelligence, or AI, as we know. Okay, so this will bring the manufacturing technology into a new level. And the pillars of IR 4.0, there are 9 of them. And this is also, if you learn about IR 4.0, then you will find this, the 9 technological pillars of IR 4.0, which are IoT, big data, cloud computing, advanced simulation, autonomous systems, universal integration, augmented reality, and additive manufacture, and cybersecurity. Yeah. So all of this. Okay. So why this IR 4.0 becomes has become so important, and so many governments and businesses look into this and take this very seriously, including the governments in Malaysia and Indonesia as well. Yeah, and then for the academia like us, in Malaysia, in our university, IIUM, we have to start. We have started actually embedding IR 4.0 into our courses, and one of the decision that we have made also to make sure that our students, I'm from Department of Mechatronics, are familiar with software programming, which we think be the core of this IR 4.0. Right. So what are the opportunities? Yeah, in terms of course, it's potentially. By the way, this slide or infography is presented by MITI. Here is in Malaysian Ministry of Industrial Trade. International Trade and Industry. So in terms of cost, it could potentially eliminate waste and losses, and then eliminate human dependency. Companies will cut so many labor force can be reduced significantly. This can be good, can be not good. For maybe for countries like Indonesia that we have so many people at the working age, this has to be considered carefully. And in terms of cost, increase productivity as well. By using all the technology, we have the optimization and so on by using the big data analysis, and this potentially can lead to increased productivity. And then from the customer's point of view, which are the people basically, the one who use the product of this manufacturing industry, they can have mass personalization, more customizable products. Yeah, so maybe they can choose the color and everything. It's unlike at the beginning of the 20th century, there was a phrase saying that you can choose any color as long as it's black. Yeah. So that was kind of the jargon for the early 20th century mass production. Yeah. So basically, the customer didn't have any choice. Yeah. If it is black, then it's black. But now with this IR 4.0 industry, or IR 4.0, then customers will have some voice, if you like, on the product, and then it can be a fast, cheaper, hopefully, and then of better quality. Yeah, again due to the optimization that we can reach by using the pillars of IR 4.0, and then customer drive for change. And again, this is basically the voice of customer can be listened. Can be heard, and then it may then be used to determine the product. So basically, if you like, this is more democratic for the customers. And then for the businesses, it will increase sales, competitiveness, and increase in the market share. Okay. Yeah, in terms of technology, the complexity, this is the opportunities for people who are doing the research. Okay. So now, after giving a bit of intro on this Industry 4.0 and NDT, non-destructive testing, I would like to share what the NDT community has been doing and is expected to do in this shortcoming future, especially. Yeah? Okay. It is expected that the Industry 4.0 technologies will enhance and transform NDT, and consequently NDT will seamlessly support the processes in IR 4.0, and therefore this will be a two-direction process. One side is the NDT, and the other side is the what we call manufacturing industry. So NDT will benefit from the technology supporting IR 4.0, the manufacturing industry. And at the same time, the manufacturing industry will be reinforced by the improved NDT, because NDT can be used and will be an important part of the manufacturing system. Yeah, as we have seen, at every stage of the production, the NDT can be importantly used. Yeah. Okay, this NDT that will be supporting the IR 4.0 has been called by some as NDT 4.0. By the way, NDT is called by different names, including NDE as well, yeah, non-destructive evolution, or some also call it as NDI, non-destructive inspection. Okay, so if we look at this chart here, this graph, this diagram, we can see how the progress of the development in NDT has been gone in parallel to the industry progress, the progress in the manufacturing industry. Yeah. And then starting from the NDE 1.0, where the NDT was very manual, probably most of it will be just basically based on visual observation. And then in the NDE 2.0, then the NDT instrumentation was start to be used. Yeah. Then NDE 3.0, in parallel to Industry 3.0, we start the digitalization of the NDE, and it become more automated as well. And finally, in the NDE 4.0, it's expected that it will be more visualized, which means that the information presented by the NDT technology will be more user-friendly, more easier for the user to interpret, to understand. And then it will also offer the in-process monitoring real time. Yeah? So you can have one of the segment in NDT is structural health monitoring, which is SHM. And then again, this is in real time monitoring the health, yeah, the integrity of the part or the product or the plant. So. Okay, so with the IR 4.0 technologies, it's expected that the problems that have been mentioned before can be solved by using this IR 4.0 technology, such as the high labor intensity, the shortage of skills, and so on. We expect that when we use the IR 4.0 technologies, that we can solve these problems that we face in NDT domain. Yeah? And in return, then obviously the NDT will also help the manufacturing industry as well, because they run hand in hand. Okay, so now I'd like to give some examples of what the researchers have been doing, yeah, in NDT, especially when they use the technologies that are supporting the IR 4.0. So starting with this one here, this shows us that NDT will be very embedded element in a manufacturing system, yeah? And it also use all this technology, the IR 4.0 technologies like the IoT, the CPS, yeah, cyber physical systems, and cloud computing as well. Yeah, this is a good example. Okay, and if you see here, this is we use some sensor. Again, this can be an NDT sensor. Yeah, starting from the evaluating the material, the raw material, and then through the machining and so on until it's become an assembly. At every stage, they are connected also to this system here, where is NDT will be part of it. Okay, and during the operation, it will be connected to this SSM system, which is structural health monitoring. Again, this is actually an NDT system as well. And again, this will connect it to this, and the information, the data, the information especially that you get from the data from all these stages then can be then communicated in real time with both the supplier and through the what we call the cloud, the IoT, and all this, it can be also transferred to the customer. Okay, so depending on where the customer is located, obviously, if it is in the close region, then we can use something else. But If it is far away in the different building or different location, or could be different city, then the internet connectivity can be used there more usefully. Yeah? Okay, so this is one example, and then another example is the use of AI, artificial intelligence, for automated data analysis, and this can help with the. If you remember that one of the problems is the complicated or unfriendly data interpretation. Yeah. So with the AI, this can be helped. Yeah. And also, this will also help in terms of the accuracy of the techniques as well. Yeah. By using the AI, so these problems can be solved. And the need for, if you look at the first point here, the need for human expert can be reduced as well. Yeah? Because we have a shortage of them in some regions, and by the use of this AI, they will help to interpret the data so that it becomes more easily to understand, to be understood by normal operators, and so on. And with the AI, it's also expected that the sensitivity, yeah, which is a very important parameter in any sensors, basically, as has also been presented by the second presenter, keynote speaker today, this morning, that the sensitivity of sensor is very important. And by the use of AI, we expect that this probability of detection can be improved as well, if you look at the blue curve. But this is just for illustration only. Okay, another use of IR 4.0 technologies is in terms of autonomous systems, including robotic systems. Yeah. This has been reported as well by many researchers. This images that I've got in here is just for some examples. Yeah. The use of robots and UAVs, yeah, on unmanned aerial vehicles is emerging in the research and development, and surely it will be in the market and be in the real use in the near future. Yeah. And some of them actually has been there. So in this example here, you can see, you can imagine this operator has to do inspection using ultrasonic system at a very high position, yeah, to do the inspection for this structure here. And then you can imagine the preparation that has to be done, yeah, preparing all these safety features. Yeah. It will take time, and also it needs some experience and skill on the side of the operator. Yeah. And then compare this to the solution by using drone. Yeah. You can save a lot of time, save a lot of cost, and then surely very significantly increased safety features. Yeah, I mean we don't need to use to have a human being at a height which is can be dangerous. Okay, and yes, there are so many people who are working on this as well. Okay, and another one, just for an example, the use of augmented reality. Again, this is one of the pillars of IR 4.0. And with the augmented reality, it helps as well for the operators to visualize the defect, for example, that has been detected in the sample or in the structure or in the material. Because otherwise, they have to look at some maybe what they call time domain signals, and then they need to interpret. But with this augmented reality technology, they can visualize better the defect, both in 2D or 3D. Yeah, this is another example. They can, although in the pipe, this defect can be actually inside, it's not visible, but with this augmented reality, it helps you to see how it looks like and where is the location of that defect. Okay, so the outlook of this research and development, especially on NDT equipment, we know that the market for NDT equipment is expected to keep growing. Yeah, and then in the future, what is very important in terms of NDT and manufacturing industry in this IR 4.0 era is the seamless integration. Yeah? So the communication between the NDT and the manufacturing system the community has to be seamless, meaning that it has good compatibility. Yeah. So the NDT community has to work with the manufacturing industry, the IR 4.0 community, to make sure that the communications, yeah, the link, yeah, if you like, between the NDT equipment and the manufacturing is good. Yeah? So they don't have incompatibility issue. And the standardization has been started, yeah? And this will be a concerted effort globally, yeah? Not just region, but globally. Okay, and the use of technological RR 4.0 pillars will change the way NDT is conducted in the future in many applications. It will be faster, more efficient, more informative, more decisive process that allows real-time information sharing. So this will open opportunities for us who are working in research in non-destructive testing, especially. Okay, now let me just briefly, I think, I'm not sure how many minutes I have left, but I will just go very briefly to my research with the hope that probably some of you have similar interest, and maybe we can work together in collaboration. The first of all, the first one is post-eddy current NDT. I've been working, actually I started working on this in my PhD, and I'm still working on this technique, yeah, till now. Currently, my focus is the use of this post-eddy current NDT for corrosion in ferromagnetic materials. Yeah? It can be pipes that used in oil and gas industry, or it can be a floor storage floor tank. Okay, and the investigation, in the investigation or in the research, I've been using some machine learning techniques as well to start to introduce this machine learning techniques to interpret the data that I get, or the data that I get from the post-eddy current sensors. Yeah, and the plots here shows the improvement. Yeah, on the right is oh no, sorry, these two are. Okay, the red one is when we use the machine learning, GPR here. And then the blue one when we use the conventional technique. So there is improvement here, especially in terms of the, what we call the error. Yeah? So the error has been reduced. Yeah? But this is just one example of the use of machine learning. And then, yes, last year also we use machine learning to interpret the data, yeah, so that we can work out the angle of slot, for example. And this work was done with Malaysia Nuclear as well. Okay, so just briefly, and then I've been also working on road surface inspection by using cameras, different types of camera, including stereo cameras. The objective is to not only to detect, but also to characterize, meaning that we want to size, yeah, the defects on the road surface, such as cracks, here, or potholes. Although the image here is not really potholes, but the objective is to be able to characterize potholes on the road, yeah, to not only to detect them, but also to be able to say what is the, for example, the surface area affected, and then what is the depth of the potholes. And we use some again some smart camera sensors, and also using some AI and cloud computing in processing the data. Okay, and the final one here is to make a prototype on an IoT-based river monitoring, where we use some sensors to monitor the quality of rivers, and then the data will be sent through the cloud to the users, and then we expect this mainly for at this stage, at this project, for governmental body use. Okay, so in conclusion, in future, RR 4.0 technologies will continue to expand the functionalities of NDT, which in turn allows NDT to be connected perfectly with the IR 4.0 manufacturing industry. And then the interconnectivity, big data analysis, cloud computing, and other technological pillars of IR 4.0 will improve NDT in terms of efficiency, accuracy, automation, and independence of human intervention. And finally, the future research and development will be exciting and attractive to the research community, for innovatively using the emerging technologies in IR 4.0, and this is supported as well by the growing market of NDT equipment in the future. Okay, I think that's all my presentation today. Thank you very much for your time and for your attention. Thank you.
All right. Thank you very much for Dr. Ali for the presentation. It is very nice presentation. And I would like to notify that we start discussion after all the speakers have deliberate the presentation. So please, if you have any question, put your question in the chat room. And then we go to the second presenter. I would like to invite Dr. Zulkifli Mohammed. And before Dr. Zulkifli make any presentation and prepare the presentation, I would like to introduce Dr. Zul for all of us. Dr. Zulkifli Mohammed is now with Faculty of Mechanical Engineering, University Teknologi Mara, Malaysia, and he is now Associate Professor. He completed his Bachelor in Engineering, in Mechanical Engineering from University Teknologi Mara, Malaysia in 2003, and then have the Master degree in Mechanical Engineering from the same university in 2006. And Dr. Zul completed his PhD program in Robotics and Intelligent System from Toyama University in 2014. And now Dr. Zul is a head of Sports Engineering and Artificial Intelligence Center in University Teknologi Mara, Malaysia. His research is in the topic of sport engineering devices, IoT, intelligent system, evolutionary algorithm, and mobile humanoid robots. And today, Dr. Zul will make any presentation in the topic of digitalization of aquaculture and environment smart monitoring. For Dr. Zul, please, the time is yours. We allocate your time around 30 minutes.
Thank you very much, Pak Iqbal. Let me share this slide first. Okay. Okay. Assalamualaikum and very good morning to Chairperson Dr. Iqbal, organizing committee, Prof. Rector, Prof. Dr. Lalu Husni, Dr. Buan, the conference chair, and my family in University of Mataram, Dr. Dewi, Pak Ali, Pak Misbah, Pak Teli, and Pak Sugiman, and Prof. Takaumi, and all participants of ICST 2020. Thank you for having me here today. Last year, I was sharing about sports engineering, but this year it is more to the AI part of our team. With the topic of, sorry, I need to put it here, digitalization of aquaculture and also environment monitoring using smart monitoring system. This is IoT-based solution. So this is what we are doing for the past 1 or 2 years back during this COVID-19, and also when the center starts. So the presentation is going to be divided into 3 sections. One is on my team, what we are doing, and then second is the aquaculture part, and then the final one will be the environment monitoring. So a little bit about me, but I had been introduced by Dr. Iqbal. This is a little bit about UIDM. We are very big actually. In each state, at least one of our campus is there. The total enrollment of 160,000 now currently. And for your information, the latest news is there is no more Faculty of Mechanical Engineering in our faculty. We are combined together now. We are called College of Engineering. So all 4 engineering faculties now combined into one faculty. Okay, a little bit about our center. It is driven actually by IoT and IR 4.0. This is due lack to local talent, local programmer, local product of IoT solution. So this is one thing that we want to venture in. And then in 2018, there is one company that is believing in us, in our team, invest some thousands of ringgit to develop our own product on our IoT solution for any application. So the target is to develop a universal solution for engineering application or other type of application. So it is also to fulfill the government IR 4.0 policy. We start with less than 50 ringgit in our pocket, but now we secure more than 500,000 grant. Hopefully by next year it's going to be more, inshallah. The main objective, our center is called sports engineering because we are focusing on sport, but the other division is focusing on AI and IoT. So it is both is complementing each other. And it is good to have both actually because the solution and the grant and also the funding is coming from the AI division. It is very hard to get sports grant directly from the government. It is not there yet because IoT in sport is very new here in our region. So this is our team. Consists of different university. We have formed one society. It is called Sports Engineering Malaysian Sports Technology Association. This year. So it is a big team. Consists of many university and also Institute Sukan Negara. There are 2 members. Said and Fauzi is from Institute Sukan Negara. So we have technical team and also different type of background. We have designer. We have sportsmen. So some of our activities, we are welcome international internships from other university also, from Japan, our own faculty, and also from other faculty from sports engineering. They are learning about IoT in different area. So we are welcome anybody want to do internship in our lab. We're also reaching out school for STEM program. It is more than 20 school now. We are coaching. And then we have our markas here. We call it markas. So everybody is very happy in this lab. Hopefully, one day you can come and visit us here. So we also have a succession plan and human resource development. We form a student company. It is called Smart Horizon. We do business mentoring in order for them to do an IoT-based solution in a company, programmer, designer, and also developer. So this is a little bit about our center. So now we go to IR 4.0. I think Dr. Ali has mentioned a little bit on IR 4.0, but mine is a little bit different. I have 11 pillars instead of 9. It is more 2. It is 11, not 9. Mine is a little bit different because we are going into the business model also. But we are focusing on the only 4 pillar core or the IR 4.0. So we are covered all these 4 in our solution in our lab. We do 3D printing, additive manufacturing, not only PLA type of printing. We're also doing a resin type, 3 type of additive manufacturing, and we also have metal 3D printing now to do prototyping, to ease the prototyping process. We have IoT, our main core, and also big data. We have our own server. Sorry. So these are the building block of IoT. There are 4 actually. One is the acquisition part, the sensing part, this one. The identification, the sensing, the data acquisition, the data processing is here. and then it will be sent to the aggregator. So all this computation, data analysis, algorithm, arithmetic, it will be implemented in this section, and then we transfer to the communication channel. So this is, we are using communication protocol to transport the data, the value, and also to the cloud and server system. And finally, the monitoring and dashboarding. So it is called service and semantic. So here we can see what are the value, the control prediction and control and also prediction data. So in general application, there's a lot of IoT application, as we can hear here, can see here in civil, mechanical, and electrical in general, and also chemical engineering. But we want to focus it in the different area, not on engineering itself, but we are focusing on a different type of application. So, for example, a repository system. This one we are focusing. We have one solution for Faculty of Applied Science. They have a lot of chemical that need to be stored and record the data, the in and out. So we are proposing a solution for them. But for today session, I will focus on flood and gas monitoring, agriculture, and also aquaculture. The rest is we have the solution, but we will do it in different time, I think, because half an hour is not enough, I think so. So this is a little bit about digitalization. What are the issues? So I have focused on 5 issues. One is system integration, the compatibility of the hardware and software. And secondly, the solution, the cost, it is very expensive. And also we have security issues, infrastructure, network connectivity, training and awareness. We are focusing on these 5 issues. Our center is focusing on how to solve this kind of issues. So the challenges and opportunities. So from that 5, we can see that the system integration is going to be the main problem will be the gateway, the transmitter, the sensor, the electronic. As the sensor is very important because I think that there is no local sensor developer yet in Malaysia, even though we have a clean room and a good research center, but still we don't have any our own sensor locally. So most of the sensor is available in China and in Korea and Japan and also United States. So it is hard for us to get a good sensor locally. We have a lab-based sensor, but it is not good for industrial application. For demonstration and for training is okay, but it is not good for industry application. So the solution, very high price, retail price, require expert. The training is limited and very expensive. Network, low connectivity, especially on the rural area. If you want to do agriculture, you cannot do it in town or city unless you have a vertical farming solution. And data security, hardware security, and also device security. So this is our solution. We provide a lot of training since 2018. We have conducted 33 training. The recent one is last month. We conduct a virtual. This month. We conduct a virtual training, IoT training regularly for 1 year. I think it is more than 30 times, at least twice a month. So this is since end of 2018. So it has been 2 years, I think. So we also teach a lecturer from IPT and also industry. So another solution, if we have any connectivity problem, we have a manufacturing problem, we do consultation. We collaborate with all researchers and also here with Telecom Malaysia. We try to settle network problem with Telecom last time in Perak because the connection is not good in our case study place. We'll also have collaboration with developer of a PCB board from electrical engineering company. So it is, I think it is good to have a greater collaboration numbers of collaboration in order for us to grow and to move forward. So awareness, we do a lot of STEM program exhibition all over Malaysia, not only student, also international student. We are welcoming twice last year. I think before COVID-19, it was 2 universities coming from Japan, and also all over Malaysia, we do STEM program and mentoring IoT-based solution to school, not only to university, or it's also to school. And then we do prototyping with partners, industry partner. We do a thermal scanner during the COVID-19. I think I've shared this one during the previous session webinar. And also we partner with training company to provide training, IoT training. So I will share, I think we can share this slide with you all in order to learn how to do this. And then we have our IoT system partner, MH5 Sdn Bhd. So I will show you later the solution. So it is this is the company that willing to provide an industrial grant for us to do the R&D on IoT solution. So we have international partner from China. They are providing all type of sensors and good feedback from them. We communicate in a two-way, how to connect, how to to assemble, what are the problems. There's a lot of problems to do system integration, but they are very helpful. And we have another one in Korea, I think, for gas sensor. So sensor alone in Malaysia, in our region, there it is not available locally. If there is one, please be our partner. We love to do a collaboration with local actually. And then this is our product of IoT. We have our own gateway. This will be launched. It had been utilized in 2 places. It will be launched next year by our VC. I think we are arranging a program with this. This is our gateway and also receiver. As you can see, this one is our gateway, and this one is our receiver. As you can see, this is a 3D printing. This is additive manufacturing. But now we are focusing on the final product. We need to do a different manufacturing process. So we call it as next specs to go internationally. This is our own gateway and also transmitter. We have our own logo in the board, PCB board. So we have our solution. I think Dr. Lee has mentioned about custom need from the user. I think this is one of the solution that we can do. Whatever the user want, we give the look to the dashboard. What are the data? At the end of the presentation, I will show you the live data from the whatever we feed to the system. So this is very customized. It is done by our team and our students. So it is good for the end user. Well, they can put their logos, their picture on their dashboard. So it is been used in few company and also football team. Okay, our own UITM FC football team. We have used it. I will show you later in the live data feedback. So we also have our own motor driver product and also thermal scanner, the one in the background, the one in the background, and this one is motor driver, our own brand here. This is the old logo. We have a new logo here. So we have utilized this one in training and also used by other researcher in our collaboration team. So this is our partner. So we have ISN, we have UTM, we have UITM FC. So we, as you can see, UITM FC is in the Super League. We are supporting our team in sports technology, sports engineering, data analysis, and also data acquisition using drone, using camera vision system. Hopefully we'll collaborate with Dr. Ali soon here. It's going to be IIUM, I think, in here soon. So we have collaborated with University Mataram, a lot of discussion with Dr. Misbah also and Dr. Ali. Inshallah, we will meet soon. So now focusing on aquaculture. So it is since 2018, I think. This is triggered by one of the user here. This is Encik Tarmizi. We call it Macrobrachium rosenbergi. So the prawn, a small prawn. I don't know what is the word, correct word, but the term is called Macrobrachium rosenbergi. So they are using low tech, so they have to collect data manually each half an hour, maybe 1 hour. But during night, it is very hard for them to maintain the temperature, to collect the data of the system. So they come up with these issues, and then we try to solve this one. So this collaboration actually with Faculty of Business, not only engineering, it is Faculty of Business. and also Faculty of Accounting, Applied Science, Mechanical, and also Telecom Malaysia. So the end user is Manjung Aquabest, Sdn Bhd. Okay, it is the demand is very high. So, but the hatchery need to produce more. The demand is 7 million, but they can only manage to produce 2 million per cycle. So it is very hard to keep up with the demand. So a lot of Malaysian people eat prawn. You know? So these are the issue. So one cycle is going to be at 35 days. So within these 35 days, we need to maintain the ammonia level, the water level, the pH level, the DO, and also the temperature to be maintained from day one, stage one, into day 35, the final stage. So the issue is when we put 70,000 of microbrachium Rosenbergi into the tank, it is only, I think, around 40 to 50,000 is alive. The rest is die. It is during the peak season, like this time, end of the year. It is a lot of raining, so it's going to be the temperature is going down, especially during 4 a.m. to 6 a.m. That is not from our observation. It is during that time the temperature is going less than 27. It is not good. So they tend to eat each other. So that is one of the problem. So that from there we come with some solution to do the harvest prediction, feed optimization, water quality, and also remote monitoring. So these are the cycle of all system. So we have covered this one, the field sensor, and also remote monitoring. So we need to go further on this part, autonomous system, feeding optimization, on also harvest prediction. So the current solution is we have covered the field sensor and also remote monitoring. Later we show you the detail. So this is the sensor that we are the data that we are collecting. One is dissolved oxygen. The threshold must be more than 4 milligram per liter. If it is less than this, they will get very aggressive and will eat each other. All this data, it is the technical data, it is coming from our system, but the input of the threshold it is coming from our partner. It is also from papers. We compare the data that provided by Encik Tarmizi and also from papers, journal papers. It is comparable and it is good data, whatever the input from the end user. So all this data is in the calculation of the to set the threshold, the upper limit and the lower limit of the system. The ammonia level must be less than 0.5. The temperature must be in this range. If it's less, it's not good. If it is greater than 30, it is also not good. So the pH level need to be in this area. This is for Lumut Manjung Aquabest. So we divide it into two. One is quality, water quality, another one is nutrient. So this is the data transmission of the system. So we have the data acquisition using Modbus, LoRa. So we have solved the issue of network. Now we are using long range without internet. We also can transfer data from rural area to our receiver. So we are using LoRa system. So the transmitter that I showed you before, it is equipped with LoRa technology. And also we have the data transport. So this is the IoT block. And also finally we display on the dashboard. Cool. So this is the proposed dashboard. This is on slide. I'll show you the real one later. So this we will monitor this DO, ammonia, pH, and temperature. So this is the real data dashboard that proposed in the Pusat Pemeliharaan Udang Galah Lumut Perak, owned by Jabatan Perikanan Malaysia. It has been installed partially. Now it's going to be full 4 tank will be installed end of this month, within another 2 weeks. Now we're integrating all the sensor and also hardware in the lab. and also calibration process before we send to the PPUG. So I will show you this part on real time. So this is the real data, what you can see here. We can see this is the data. I think they are shutting this thing off, current data. So it is no data at all now. So we have 4 sections. So each section, they will be having 5 data. So we can also see the trend, dissolved oxygen trend, temperature trend. So from here, sorry, because the data is off, I think. I think the owner is at the end of the final stage cycle. So they just shut down everything. And then you will have this data for yearly, weekly, and also monthly. So it depends on you. It depends on the end user, what kind of data you want. So from here, you can manage to have daily data, weekly data, in order for you to propose further to get grant, and also to to have a manual in order for other end user want to to do the same system. So how do you do that? What is the good data? What is the best value that we need to have in order to have a good production of microbrachium Rosenbergi? So this is the existing data. This is for PPUG owned by Jabatan Perikanan Malaysia. And so the same thing. So I show you the live one just now. And the next section is going to be water quality management. We are proposing this system. So this is our proposal, not our picture, but this is our proposal. The same principle. We want to control the water quality indoor. This is for indoor solution. For outdoor, it's going to be a different solution. So these are the next section. Okay. So the next section is this one. This is agriculture. It looks the same, but this one is for agriculture. The previous one is for aquaculture. So the different thing will be the sensor actually, and also the system, the irrigation system is slightly different compared to aquaculture, because aquaculture, what we are focusing is indoor, but in next year, I think Jabatan Perikanan is calling us for outdoor solution. Because there are problem on riptide, because last time riptide is very bad for growth, because it just block oxygen from the fish. So I think it is one good input from Jabatan Perikanan for us to solve the issue using vision system. Maybe we can collaborate on that part. So we are proposing one ecosystem, one big ecosystem from the small system. So instead of having one solution of chili or any vegetable, we will propose a one ecosystem, one IoT ecosystem. So this is on proposal. We have proposed this one to Jabatan Perikanan last time, to Ministry of Agriculture. They are looking with it because end of the year, the budget is not there yet. So I think next year is going to be a different thing maybe. So these are the for agriculture. Nothing much to show because this is the proposal part only. So, but this one it is there. This is collaboration with MH Delima Sdn Bhd, the one that invests in our IoT solution. We implement the system in their farm, a chili farm. It is a polybag chili farm. One polybag we have 2 chili plant. So we monitor all this data and also pumping the nutrient to the chili bag. So this is owned by MH Delima, so our partner in IoT solution. So the challenge are here actually, the communication, the sensor, and also microcontroller. But we have solved some of the issue. We are looking partner on sensor actually. If you can produce good sensor on agriculture or aquaculture, and it's type of sensor that can be utilized, I think it is good for us to have collaboration with sensor developer, local sensor developer, even in our region. It is hard to get a good sensor. We have done this before with sensor that available in Shopee, in Lazada. It is not good. None of it is good. It is bad actually. It is good. It is for lab purpose. Training is good, but for industry to prove the concept, it is okay. But for real application, I think it is very challenging to have a good sensor. and also system. So now we are here actually in harvest prediction and also feed optimization. We need to control and optimize. Now we control only the valve of the dissolved oxygen, but I think coming soon it's going to be here. So this is our solution. We have SAM, we call it SAM, Smart Aquaculture Monitoring System. We have presented in few occasions. We have launched it in the previous, I think last year we have launched it, SAMS. This is our first prototype. It is not prototype. It has been utilized in Manjung Akabes. What you can see here, it is displayed on his phone, like here. So Encik Tarmizi is very happy now because all the first prototype is going to be implemented in his hatchery system. So becoming our partner, so anything new is going to be there first to be utilized. So there are two here. One is PPUG and another one is Encik Tarmizi. So they are having this data now on their phone. So whatever you have seen here, this is data for last cycle. So the next cycle is going to be a different one. We are proposing a new system. It is called NextPlex. The previous one, we call it SAMS MK2. The one that I show you before is NextPlex. So this is with PPUG. PPUG is stand for Penternakan Udang Galah, Pusat Penternakan Udang Galah. It is located 100 kilometers away from our lab. So we can manage to monitor and also control the system there in our lab. So what you can see here, these are the solution. So end of this month, it's got another 2 weeks. We're going to be there to install 100% of the system, 100%. So now it is 80%. So on environment, this is a collaboration with three fire department. One is Bintulu Port Fire Department. So we monitor the gases of their port. So this is the proposal. It is ongoing. We have purchased the gas sensor from overseas. Again, there is no gas sensor locally, even in our region, even in Singapore, it's not there. The one that we have is from Korea. For gas sensor, it is from Korea because they need to comply with standard with safety and also with comply to CRIM and also the procedure need to be compliant. So it is very hard to get a certified type of sensor locally. So we collaborate with one company in Korea to do to give us the sensor. Once it is installed, I will share with you the data, live data, because this one is not yet online. It is still offline. Okay, it's going to be next year. We have another few months to settle this project. They have granted our team the phase one. So next one is going to be heat map monitoring. To look what are the how the gas is distributed if something happen on the port. So this is very big actually in Bintulu. So due to COVID-19, so we cannot be there. So this is our solution. We have purchased all this part. We have settled, and then we are using NextPlex as our solution of gateway and transmitter. So we have a total solution of this one. We have a dashboard developer also. So it depends on the user how they want to display. The second one is Jinjiang Fire Department, Fire and Rescue Department. This is Jinjiang Dragon. They call themselves as Jinjiang Dragon. They are monitoring a flood happening in Petaling Jaya and also Kuala Lumpur. One is in Naza Ducati. It is one in Ducati PJ. We have installed the system at the back of their premise. Another one is in Tun Razak Exchange parking lot, because there's a lot of flood occurring over there because the parking lot is utilized by Cycle Carriage Malaysia. It is a Mercedes-Benz distributor in Malaysia, so it is very hard for them to monitor. So this is a collaboration with Jinjiang Fire Department. So we have installed the system, the proposed system, just like this. So this is the data. There's the unmoving data. I will show you the moving data here. So these are the data, but it is still again it is offline, as you can see here. So there's no data at all. But now it's raining. I think I don't know why they are shutting this one off. It's supposed to be green here because there's a lot of raining in our region now. It's supposed to be green. So this is live data. As you can see, it is blinking here. It's supposed to be some reading on water level. So this is very simple and very cheap. It costs only 3,000 ringgit, so very cheap with dashboard. So this is collaboration work with Bomba Jinjang. Okay, finally, this one, another one. Finally, we have Sri Hartamas. This is not the fire department, Sri Hartamas Fire Department and Rescue. They are proposing, they have issues when they go site because this department, they are dealing with hazardous gas. They don't have any equipment to do that, to monitor. So they come with this problem where we try to do the solution. So we propose them an IoT monitoring system on their proposed system. We do 3D printing over here. So this is a simple one, 3D printed system, mounted a camera here and also sensor. We have gas sensor. They have issue, they have to enter manually. So I will show you the video here. So now it is like this. So this is they are entering manually, the on site. So this one is using the system. So the data here, it is on their handphone, okay, on their handphone. So the system is inside. So when they're reaching some point, it just peak and then get back. So now they know what is the value here in this carbon monoxide data reading. So this is with Sri Hartamas Fire Department. So this is also very cheap for them because due to collaboration, so it gives them a special price. And then they also use a lab type sensor. It is not industrial based sensor because the sensor is very, very cheap. I think it is around less than 100 ringgit. It is 60 to 50 ringgit type of sensor, but still manage to transfer data to the phone without any problem. So for proof of concept, it is good. In order for them to propose a robust system, I think it is need to improve a lot on the design. Okay, way forward. So this is the final few slide. Now we are doing a lot of. Actually, this is not one man job. It is a team job. As you can see, what my team members. There's a lot of team members over there. They are focusing on smart IoT timing gate system. This is for sport. Smart IoT fishery weighing system. This is also for aquaculture, sport vision. I have 2 PhD students on sport vision on football. It has been utilized with UITM FC. It is lucky for us. We have sports engineering, sport and science faculty. Or the one that I want to show another one. Sorry. This is the solution that used to be from UITM FC. As you can see here, all the data of the player is here. This is not published yet, so it will be launched next year. A new team, as you can see, all the players here. So we can see the data, the fitness report of the UITM FC player. So the data of fatigue level. This is coming from sensor, and also our Mayon system, our EMG system is fit directly to the player. So this is good for sports technology research area. So we can have all data for each player. So the same system had been proposed to Institute Sukarnegara. So hopefully they will take up this one because we need to prove it to prove with our team first. So that's why we have UITMFC having all the research for them first. Only then we can show to other people. Our target is to have a system that is affordable by any user, by school, by low income football club. So everybody can use with limited budget. So we can just do it for them. Another one is we also do for school actually. This is for school. So this is kelas tambahan sekolah menengah Muzaffar Shah. They're using the same principle of data. So they are using QR code. So the cheapest one, QR code using smartphone, and the data is up here. We can see school program, extra class, what are the score in each subject. This is a non-contact during COVID because it is hard to do contact face-to-face. So they're just coming using QR code and others. So teacher when utilize it. This has been utilized by 6 schools. So we sell this one solution to the school with CSR also. Hopefully we can utilize in all over Malaysia. So one thing that we are focusing now on this area, we have a Jemaah Haji IoT tracking. It's supposed to be there in Makkah this year, but now it is COVID, it's not there. And we have a smart pipe leakage monitoring. This is also transferring data all cloud because we have our own server now. So we are having all the data here parked in the cloud. So the data will be signed NDA with the user and also us. And recently we go to financial technology, the e-wallet stuff, and also the Islamic transaction, fintech, everything. We are venturing on this part also. And also border monitoring by team Dr. Hanif. So our technical lead is Dr. Muhammad Hanif Ramli. He's the leader of our AI division. A lot of research going on this area. So we are opening a collaboration with all of participants today. We are promoting complementing research. There is no competing in our term. So we are open. You may come, you may look, and maybe I can show you what is happening in our lab. Currently, actually this one is currently in our lab. So it is monitored remotely anywhere the lab. So you can come at any time or virtually coming to the lab. Okay, with that, we are also available in social media. I think all social media is there, but we are active in Facebook. So you can follow us in Facebook. Here, just search sports engineering and artificial intelligence center is going to be there. We are located in the main campus, Shah Alam, and also these are the. I think I will share this one with organizer. So with that, I would like to thank end my presentation and thank you very much. So you can just contact me through WhatsApp also. So with that, I will return to our chairperson, Mr. Dr. Iqbal. Thank you very much.
Thank you very much, Dr. Zul, for the very nice presentation. There are a lot of information about the research and also the institution there, and then so we can collaborate in the future. And I think it will be very nice discussion after this. But for the participant who would like to have any question, please put your question in the chat room. We are going to the next presenter. I would like to invite Professor Dr. Engineering Igede Pasek Sutawijaya. While Prof. Sutawijaya prepare for the presentation, I would like to introduce him. Professor Igede Pasek Sutawijaya is now the head of Department of Informatics Engineering, Universitas Mataram, and he finished his bachelor degree in Gajah Mada University, Universitas Gajah Mada, in 1997, and then he went to the master program at the same university, and he completed a master degree in 2001. And Dr. Pasek also did his PhD in Kumamoto University from 2007 to 2010. Professor Sutawijaya also have conducted at least 2 activity postdoctoral in Kumamoto University and research fellowship at Kumamoto University. And Professor Sutawijaya will have the presentation with the topic of artificial intelligence and its application to support smart society. For Professor Sutawijaya, please, the time is yours.
Thank you, Dr. Ibal. It's a great honor for me to be here to give a presentation to all of you. And let me say hello to Dr. Ali, to Dr. Zulkifli, who has been given previous presentation regarding to this in this conference. Let me share my screen firstly. Okay, can you see my screen?
Yes, clearly.
Okay. Let's start my talk today. Thank you for your nice introduction for Dr. Iqbal. Today, I would like to talk about the artificial intelligence AI and its application to support the smart society. And I'm from the informatics department, Faculty of Engineering, Universitas Mataram. As already mentioned earlier, that from both of our previous keynotes, that currently we're already in Industry 4.0 with the emphasis on IoT, AI, smart machine, and communication, intelligent machine, and multitasking system. So, but I add some information maybe in terms of the society. Currently, we're already in the Society 5.0, with similar to the Industry 4.0, with utilizing IoT, AI, big data, and robotics. And also the multitasking system is really needed in order to support the smart society. In Industry 4.0, that focusing on automation, but here in Society 5.0, human knowledge is used or is utilized also for the optimization. So here we given a little bit about the Society 5.0 that was introduced by Japan in 2017. It's called as Super Smart Society. This is an example. I think previously already well presented by the previous keynotes that there are many applications in IoT and AI. But here I give an example that how the drone has been used to help an elderly and people meet to their needs. In this case, there is 2 points that there is a drones with the AI application inside, and then there is a human who is the operator of the drones and the automatic system that help the elderly to fulfill their needs. And currently also there is an application or AI-based health system that also support for the elderly. In this case, like in Indonesia, there's a rural area, there is no many, how to say, medical human resources that is limited in the city. So for the rural area, they need also the medical system. So such kind of system is really needed by the people like in our regions. This is the little bit of comparisons that is already clear that mainly that Industry 4.0 is emphasizing on the automation of the system, but in the society, not only the automation, but also in the for the people. In this case, the people knowledge is needed to optimizing the productivity. And by Society 5.0, the technology or the automation system is as a support system in order to speed up the work and help the people to support their work or their needs. This is a little bit the artificial intelligence is already known, well known by the people who focusing on the AI, but for because the audience is ranged from many field of science. So the main key point in the AI is a model or an imitation of human intelligence system that can think like a humans. So next is there are 4 types of AI actually that's we call as a model or system or algorithm that enables to do 4 kind of things. Thinking like humans, thinking rationally, acting like human, and acting rationally. This is an example, maybe already known by the expertise who works in the robotics. This is a humanoid robotics who can, which can dancing to follow the music that's given. And also there is a robot that how the robot can communicate with the partners. In this case, the partner is human being. It's totally, if you come to Japan, you will find many robotics in the hotel as the front officer. So if we compare that the AI has versus the human intelligence, even though the human intelligence is time dependent and cannot be duplicated and very costly, but it's more creative. And when human being taken decision, they will focus on broad area, a broad we use broad sensors, we call that. We use all of the system in human being as a sensor, as a reference to make a decision. It means that human being still has the complicated intelligence. But in AI, it can be more permanent and can be easily to duplicate and work very fastly, but it still have a disadvantage because the AI usually only work in a specific case. For example, if you're training an image for face recognition, if you put an imitation of face in front of or in front of the roof, so the system cannot be recognized as a face. So it means that the AI even though they have many advantages, but they still have the disadvantages. And then here we talks about AI touching for smart society. In this case, I especially talking about that what we have done for the Lombok Society Islands. In this case, I have been developed in our lab expert system for agriculture, medical, and for the NDT also, non-destructive testing, we call this crack analyzer. And also for medical, we make smart ear, nose, throat, ENT units. We collaborate with the medical science in Universitas Mataram. And we also develop an phone away application which can perform an image and video quarantines. And the next is currently we still going on the CNN classification for Sasak and Bima character. This system is really needed by the society because not many people in Lombok Islands and Sumbawa Islands, they still learn about the Sasak and Bima characters. And also already mentioned earlier by Dr. Kipli is very clearly that how the IoT has been developed or implemented for smart farming. In this case is smart farming, there is 6 key points in the key points. First is sensing technology. Similar with Dr. Sukupli, when our lab apply the IoT, we still have problem with the sensors, and the sensor that available in the market is only good for prove the model, but after the implementation, we need many improvement or developments. Second is software application. This is quite, I think currently all of the people in IT department are already known that the software application is quite little bit easy to develop, and communication also already available, telematic positioning technology with GPS and hardware and software. And this one is very a challenge, and the data analytic solution we also can do real time. And then in order to develop the system for smart something, I mean the smart system for agriculture, for tourism, and etc. There are four cycle that we have to follow. First is the observation. We need a sensor that has been explained clearly by the Dr. Zulkifli. In this case, we need a good sensor in order to obtain the observational data, yeah, from the what is the implementation of the IoT. And then the diagnostic, the data will feed up into the IoT platform. In this case, usually we use the cloud computing technology, and then make some simple analysis in order to identify any dependencies or needs, and then use the expert system for further diagnostic. And then for decision, from the feed data, we try find the deficiencies and the problems, and then we can solve by the decision system. In this case, we can use the machine learning. And there are many machine learning system or library that can be employed here to make the decision. And after decision, we take an action based on decision that we taken. In this case, for example, if a plant needs water, based on the data that we already understand that the plant is already need to watering, or the soil is very dry, and then the actuator will on to make water to the plants. And then the expert system for agriculture. Here we develop to support our farmers in Lombok Highlands that our lab already collaborates with the farmer in close to Narmada to make the expert system for diagnosing rice disease, chili disease, and mild diseases. Not all that I will present you, but I just give one example here. But our system is working based on the multi-stage algorithm called as forward chaining and Dempster server, and forward chaining and certainty factors. Here is the architecture of what we have developed so far. Here there is a user. This is well known by the IT developers. There is a user, there's a expert here. In this case, we collaborate with 3 experts from the Dinas Pertanian or Agriculture Department, Provinsi NTB or West Nusa Tenggara Province, and from the Mataram University. And then based on the 3 experts, we acquire the knowledge, and then from the knowledge and the information from the user, we make an inference engines. Then the different engines here, we based on 2 well-known algorithms, is forward chaining and Dempster server. And from these models, and then we developed a mobile application. Especially here, we develop for the Android mobile media, because in Lombok Halian, mostly the people use Android smartphone. And then the data here that we use is first is disease and the symptom that we got from the expert and from the literatures and from the farmers. And the second is the belief that we getting or we acquire from the experts, with reference the belief of expert on the symptom related to the disease. Here, the value is range 10 to 1, and the more confident of expert to the symptom is will be give higher value for the weights. Next, in this example, it's quite technical also. Suppose that we have to input data here, and then we create the rule based on forward chaining, and then based on Dempster server, we calculate the density of the symptoms, of the given symptoms. And then based on the highest density, we choose the appropriate disease correspond to the highest density. And the conclusion is sent to the user through the application, and it's also in its probability. Dempster server work based on 3 questions actually: belief, plausibility, and combination, as shown in this question. Based on this equation, we create an inference engines. and then implemented for mobile application. Suppose we have this data, we have two symptom here, then we also provide two diseases here, three diseases, okay, and then the weights. And then from the symptom, each symptom we calculate the mass of function, and then based on the mass of function, we perform rule of combination, and then finally we can take the conclusion. And then for the application, because we made in Indonesia for the local farmer in Lombok Island, so we developed the application using Bahasa. So we call as Sahabat Padi. In this application, we could do a diagnosis of disease and description of the disease and the help, and also what is the do for the information of the next after we diagnose the disease. Quite simple, only user will only put the symptom that is observed in the field, and then based on this symptom that's given, and the conclusion will take based on a decision that we made previously. And then here, after giving the symptom, and then we can conclude the what happened with the pedis. Here is called as Howard down bacteria with percentage 100%. And what we have to do, this is the suggestion from the system. And then how, in order to know the performance, of course, this application still need to be developed because currently we just got the accuracy about 81.1% when we evaluated using the real cases or 30 cases in the field. The testing was done collaboration with the student and the farmer in close to Narmada area. Next, we performed another AE application in our laboratory in order to support the non-destructive testing here. We developed an AA signal interpretation for develop a non-destructive testing for damage assessment. Here we work based on secondary data that we got from CGC laboratory in Kumamoto University. That of course the data is noisy, and then we need to firstly we perform the filtering using the wavelet transform. And then after we do the wavelet transform, we need to develop the feature extraction. Here we develop the feature extraction based on subband analysis that using the discrete wavelet transform. The block diagram is shown here. Suppose we have the input signal like this, and then we perform, of course, this signal is already filtered, and then we analyze this using the frequency analysis using the wavelet transform. And then based on this subband frequency, and then we perform the subband component analysis or quantization and normalization, and then we make a unions for all of the subband when they got these features. And then for the dimensional reduction, of course, because the data is very large and the size is very large due to the data is very large. Therefore, we need the dimensional reduction. We play the principal component analysis, which is based on global covariance and global means analysis and eigenvector analysis. Suppose we have X in having L classes and X classes have in K sample, and then we takes the global covariance and global means, and from those quantity, and then we perform eigenanalysis. From the eigenanalysis, we take eigenvector and eigenvalue, and then we constructing the what we call as projection matrix by selecting some of eigenvector corresponding to highest eigenvalues, and then we perform the projection. What is the benefit of this projection? Suppose we have these two classes, we note by red and blue, and suppose we have this one, this triangle. It's quite hard to understand whether this triangle belongs to blue or the reds. but by using the PCA projection, and then we can clearly transform the data into the clear classification. So here, the triangle can be classified as the blue because the triangle is close to the blue. For the classifier, we develop not only support vector machine, but also we use artificial intelligence. Another type of artificial intelligence we call as artificial neural networks. For the support vector machine, we need to define the W that fulfill this question by using the support vector here. And then based on the support vector, we need to know that the W has fulfilled this question. So if the W times the X input plus B equal to 1 is classified as 1, and minus 1 is classified as minus 1. So in this case, the formulation is we have to minimize this equation. That's for performance. Before we implementing for AA, and then we need to know whether the proposed algorithm is work for classification. In this case, we use the fault bearing detection. Suppose that we have this data. Red is representing the bad data, and then the blue is okay data or good data. And then from this one, we make some transformation the data based on the PCA that we developed previously. And then we can see clearly that the data is discriminates to each other. From this one, it's hard to discriminate, but here we can see clearly. So by doing the support vector machine classifier for nonlinear, we can get the good classification, which provide the 98% of the accuracy. However, when we implemented for a signal classification, there's the accuracy decreased around 38%. We just got to 60%. So it means that the feature of AA signal that we developed is not quite good enough. Therefore, the SPM could not find the proper classification line. And then in order to prove this condition, we also implemented the SPM for a crack analysis. In this case, we use the data from Lombok's earthquakes that cracks data from the Lombok earthquake in 2018. And then we got 97.5% of the accuracy. So it seems that the AA signal from the secondary data is not quite good. And in the future, we will develop another strategy in order to find the best AA signal. And then in order to improve the lack of the DWLTT or the wet-layer transform and PCA for feature the extraction, and then we develop an CNN-based algorithm which based on convolution analysis and fully connected networks. The block diagram looks like this one. In this case, we use for crack analysis in order to provides to classify the input data into severe, moderate, and minor data, or minor classification, or minor three type of damage. And then in this case, we need the pre-processing, of course. We do scaling and color space. Scaling is used to obtain the very variety of size of input images. Range from 32 times 32 until 96 times 96. And the color space transformation we need because we will work on the grayscale, so we need this population. And the image is scaled and dividing it by the 25 because the neural network work for data 0 to 1s. All the pre-processing is needed in order to decrease the computational time on training and testing. This is the feature extraction. We use the convolution based on kernel. I just make it clear how the kernel and convolution can work for feature extraction. And after the convolution, we take the ReLU in order to get how to say the activation function here, and then we make some fooling or decreasing the size by pooling system and the half size of the images. And then why it's work for the feature extraction, suppose is we have two sample here. This is the bird. We want to take the big hairs, the bigs with place in different place. By using the kernel or the filtering here and move around the images, and we could find the big here and the big in this case. So that's why the convolution is quite popular currently. And then in the fully connected of artificial neural network that's combined in the CNN, we need to find the best variation of how many hidden layers and how size of the neurons and how about the dropout percentage for the ANN. In this case, we try many variation of the NNs, and we find the conclusion that for the correct analyzer, we got that CNN model with 3x3 kernel provide better performance than the others size. And then for the next, and then we find the model NN is 3x3 kernel size, 1 hidden layers, and 36 neuron is provide the best performance with 99%, almost 90, more than 99% of accuracy, precision, and recall. And then in order to know the proposed method work robustly, and then we apply it using the large size of data set. You use the 40,000 images, and we compare using the our focus work, quadrics discriminant analysis and support vector machine. And then we got is the CNN is quite better. It's much better than the previous one, those previous one. And then in order to know the performance on the cracks data from the Lombok earthquake, we also tested the model. Then we got 93 point, more than 93 of accuracy, precision, and recall for the developed model. And based on this model, we developed the Android application for building assessment. So in this case, the user just need input the picture of the cracks from the building, and then the system, the engines that we develop will be classified directly what happened with the input cracks, and then based on the information, we use the expert system to define whether the building is already healthy or not healthy. In this case, for example, we did for our building in Faculty of Engineering in Gedung A or A building, we got this the minors damage. The last of the application for smart society is a smart ENT unit. In this case, is an application that integrates the endoscopy camera of air cleaning toolkits with the intelligent classification. Here, we also developed the CNN model for classifies the input image from the camera. This works is collaborates with the medical science and also civil engineering and develop the hardware. In this case, also we need the pre-processing that we implemented is normalization, cropping, and scaling. Normalization is was implemented to normalize the input image as zero mean and unity standard deviation. And cropping is used to remove the background of the images, and another scaling for decrease the computational time on conducting training and testing. And here we got the model with almost 400,000 or more than 400,000 parameters from 1,800 images of 18 classes disease. And then based on this model that we integrate with the ENT tool here, this is the units for ear, nose, and throat units hardware that we put here on application based on the Androids or mobile application. And then we put in the mobile as one camera called as endoscopy camera, which integrates together. And then this system can be worked properly because it could use for classifies the image from the camera and also bring classification for the gallery image. Suppose in the remote area, we don't have the engines yet, but you already have the sensor, and then the collecting sensor, the collecting data can be sent to the server, and the server will perform classification directly. But here's our performance still not good enough, but still in going developments in order to make the system quite robust to any variation of ENT images. And then the Android application here that they developed is still also going on, because we start this work just last year, and we propose for further budgets from our government. If I got, then it will be possible to be implemented in the rural area, especially in Lombok Island, because the doctor specialists not spread in all around area in the Lombok Islands. So in this case, we already tested that for the some 19 cases that we got from the patient, that we already provide 80% of the accuracy, and then it could be potential to be applied in health center, clinic, hospital, and learning laboratories. It's additionally also it can be used for learning tool in the medical science. And this is the last, maybe the expert system that we also developed, not based on the input of the image, but based on the symptom that we developed by students in our lab. And also we developed the application based for the Androids. The block diagram looks like in the left one. There is the user and export. It's quite similar as previously, but the different engines that develop here is based on word chaining and sensitivity factors. And then the result could provide 87% of the accuracy for the given symptoms. For the conclusion, what we have done is hopefully can support the smart society in the future in Lombok Islands. But currently, as we know, that AA and their combination will play as an important role for the smart society. And all kind of human activity in the future, as mentioned also briefly by the two keynote speakers, must be supported using the automatic and autonomous tool. And IoT based and AI will be the backbone for the creating all form of smart system. And as future work, we need the collaboration, research in any discipline for continuing developing the products and tool product to meet the smart society. That's all of my presentation. Thank you very much. I return back the time to the chairperson. Thank you.
Thank you very much, Prof. Sutawijaya. I think there will be a very or a lot of thing that you want to share about because of the limited time and also the tight schedule. So I look at the time that we have around 10 minutes to have discussion, and then I see in the chat book, in the chat room, that there are at least 2 questions from the participant. The first question is coming from Bapak Kadek Wiratama, Dr. Kadek Wiratama. This question is going to Dr. Zul, I think. So I will read the question. Very interesting to hear about aquaculture referred to IR 4.0, how to optimize, how to optimize every real time of data acquisition for station A, B, C, or D. Do you use any meta-heuristic methods such as genetic algorithms or neural network to optimize all of data applied to microcontroller. Is it clear, Dr. Zul?
Yeah, it is clear.
Yeah, this is a question for you. So the time is yours.
Thank you very much for the question, Mr. Kadewi Ratama. Actually, the calculation and the AI element, I think Prof. Gede pasti pun ada answer that question. Will be done in the aggregator section. So after the data acquisition, transmit to the microcontroller, is going to be sent to the aggregator section. So all the calculation, all the computational process is done in the aggregator. The algorithm that we utilize actually using a neural network, a simple neural network, because at the moment data is transferred within, it depends on the timing, because in critical time in the early morning, during early morning, 4 a.m. to 6 a.m., the data is transmitted every 5 minutes. But during daytime, it is half an hour per data is transmitted. And then it is transferred using a Modbus system. So all the data is pulled in one file, and then it is pushed to the cloud in one single file. It is very low processing time we need to do the process. So all the algorithm will be implemented in the aggregator section. So we just utilize a simple ANN to the system. It depends on the data size. So now we also have a data analytic solution for that. Again, it depends on the data of what we are feeding. So if it is the range is within half an hour, 1 hour, I think it is very easy to manipulate in real time. We have implement a simple ANN solution for that. Inshallah, it is will be we can show you later, hopefully during other time, how the real data is processed, and also how it will control the heating element. So actually now we are putting a heating element to the tank. So with all the temperature, if the temperature is reducing, so we just heat the tank directly. So it is a simple calculation that we implement to the system. So it just run on it can run on a small type of PC, for example, Raspberry Pi, or a smaller type of CPU. So because the data is not heavy, not every second. We can pull the data in real time in every second, but it is useless because the end user, they want it maybe half an hour. It depends, because it depends on the end user how they want the data to be fed. So we set the parameter to be that way. Thank you very much.
Thank you, Dr. Zul. I hope that the answer is answering the question from Dr. Kade. And then the second question is coming from Ninyoman Kencanawati. This Dr. Kencanawati. My question goes to Dr. Ali Sofian. You have explained that NDT offers many benefits to support Industry 4.0. As we know that the result of NDT in predicting or monitoring materials or structures is affected by many factors. I'd like to ask how to evaluate the reliability or the accuracy of the NDT measurement. Thank you. Dr. Ali, please.
All right. Okay. Yeah.
Can you clearly?
Yes, I can. Yes, thank you. Yes, thank you for the question, Dr. Kencanawati. That I've noticed that you've been doing research on NDT as well, yeah, with acoustic emission. Yes, I will try to answer this based on my experience. Although I guess because our application is different, the technique that we use also different. What I've used might not be applicable to your research. But from the research point of view, for the eddy current, especially because I've been working for corrosion evaluation, and corrosion for the samples, in terms of samples, can be done by using a manufactured controlled samples by different thickness. Because when, for example, like a plate is experiencing corrosion, it will affect the effective thickness of that plate. Yeah? So the thickness will change. So in my case, I prepare manufactured samples that have different thicknesses. Yeah. And yes, we need to make sure that the sample is as realistic as possible. For example, in terms of the material that used, yeah, and then also in terms of the structure or the layer, if possible. Like in my case, if it is insulated with some cladding, then I try to use the cladding and the pipe itself, the material of the sample, as close as possible to the reality. And ideally, we need to, especially like for me, in my case, because my background is not from the material, not from the civil engineering. So I work together with some industry as well, and some partners from, for example, Malaysia Nuclear. So they will look at the samples that we have prepared, and they give suggestions, and then we can use it. And yes, we then use the samples, do the evaluation of our technique or our sensors that we develop by comparing the results against the more established technique. Yeah, for example, if you are measuring thickness, we can compare it to this already widely used technique, for example, like ultrasonic, and so on. So then we make the comparison, and then we need to make sure that also the repeatability is there, that we are not just using one single set of data, but we need to collect a sufficient number of data, yeah, so that we know the what we call the repeatability, and then the precision as well of the technique. Yes, this for the research. Yeah. And then when it comes to the application, real application in the field, then industry actually use this a parameter called probability of detection. Yeah, and to get this, we would like to have a real samples with real defects, and this can be expensive exercise, and then not all of us will have access to this. But if you can have access to the real samples with real defects, then that will be very useful. In my case, for example, I'm still working on the prototype, and then we are expecting to have some evaluation in the field at the beginning of next year, inshallah. So yes, I think I hope that answers your question. Thank you.
Thank you, Dr. Ali. I think because of the very limited time and also the very tight schedule, I would like to thanks to the three keynote speakers, Dr. Ali Sofian, Dr. Zulkifli, Professor Sutawijaya, for the very nice presentation and also sharing the information. So I don't need to make any conclusion, because there are a lot of topic, a lot of aspect that we have to discuss about, and then we hope that we can have any other platform to discuss more detail. Thank you very much for all the keynote speakers, and please give a big applause for them. I think that's all the discussion for this session, and then I will return back the time to the MC. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang.
Okay. Thank you. Thank you very much, everyone. Thank you.
Thank you, Mr. Samsu, for moderating the second keynote speeches today. Ladies and gentlemen, we have reached a conclusion of our opening ceremony. But before I end this opening, I would like to inform you the following matters. First, we have organized in total 2 parallel sessions that you can join, which consist of 6 topics. First parallel sessions will be starting at 1 until 3:30 p.m. and second parallel sessions will be conducted at 4 until 5:50 p.m. For further information and schedule, you may see the program book that we have delivered to you. Second, information to all presenters, please kindly rename your name in Zoom application according to your room. This will make the committees easier to adding you into breakout room. Third, for moderators of plenary sessions, there will be short briefing right after this in order to inform you regarding the procedures of the plenary sessions. And the fourth, the lunch break will only take place in 30 minutes, and we invite all the moderators, presenters, and participants to join the parallel sessions at 1 p.m. Ladies and gentlemen, thank you for your participating in our opening ceremony today. I'm Sinta, your Master of Ceremony, represented the organizing committee. Would like to remind you also to follow the health protocol, wearing masks, and keep social distancing. Stay healthy, happy, grateful, have a great day, and I'll see you at 1 p.m. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Ali, Ketua Lembaga Penelitian dan Pengabdian kepada Masyarakat Universitas Mataram, atau yang kita kenal sebagai LPPM UNRAM. Adapun tupoksi LPPM Universitas Mataram adalah mengawal terwujudnya visi Universitas Mataram sebagai lembaga pendidikan berbasis riset dan berdaya saing internasional. Untuk mewujudkan visi tersebut, LPPM UNRAM memiliki koordinator di bidang penelitian dan koordinator di bidang pengabdian. Di bidang penelitian, UNRAM memiliki beberapa pusat penelitian, diantaranya pusat penelitian agribisnis, pusat penelitian perencanaan wilayah dan pedesaan, pusat penelitian pengembangan regional, pusat penelitian lingkungan hidup, dan pusat penelitian gender dan anak, dan beberapa yang lain. Untuk mendukung pusat-pusat penelitian tersebut, UNRAM juga memiliki beberapa pusat unggulan IPTEK, diantaranya pusat unggulan Gaharu, pusat unggulan geomagnetik, pusat unggulan ternak Indonesia besar, dan pusat unggulan imunobioscience serta bioteknologi. Di bidang pengabdian, UNRAM memiliki beberapa pusat layanan seperti pusat layanan hak cipta, kedua pelayanan untuk KKN, tiga pusat inkubator, dan beberapa yang lain. Untuk mewujudkan visi UNRAM tersebut, LPPM akan menggerakkan semua komponen sivitas akademika Universitas Mataram untuk mewujudkan riset yang berdaya saing internasional dan melakukan pengabdian yang bermanfaat untuk masyarakat sekitar.
LPPM Universitas Mataram pada tahun 2019 berdasarkan Surat Nomor B/990/E3/RA 2019 dari Ristek Dikti tentang peringkat perguruan tinggi berbasis kinerja pengabdian kepada masyarakat, maka LPPM Universitas Mataram berada pada klaster sangat bagus, yaitu di urutan nomor 5 di atas ITB maupun UNUN. Sedangkan di bidang penelitian berdasarkan surat nomor B/850/E2RS04 2019, LPPM UNRAM termasuk klaster mandiri berada di urutan 24 dari 1.977 perguruan tinggi yang berada di Indonesia. Penilaian di atas dihasilkan dari penilaian kinerja kelembagaan untuk bidang penelitian dan pengabdian kepada masyarakat yang berasal dari komponen 1. Dana manajemen meliputi kegiatan penjaminan mutu dan sumber daya manusia, rekrutmen penilaian internal, seleksi usulan kegiatan, monet internal, tindak lanjut hasil penelitian, kegiatan penghargaan. Yang kedua, berasal dari sumber dana internal perguruan tinggi. Yang ketiga, bidang unggulan. Dan yang keempat, luaran penelitian yang meliputi publikasi ilmiah, keynote speaker dalam pertemuan ilmiah, pemakalah dalam pertemuan ilmiah, serta hak kekayaan intelektual dan luaran lainnya. Yang terakhir adalah hilirisasi hasil penelitian. Untuk mempertahankan dan meningkatkan peringkat di atas, maka diperlukan adanya peningkatan kinerja kelembagaan dari semua pihak terkait dengan penilaian kelembagaan di bidang penelitian maupun di bidang PPN.
Alhamdulillah, sejak tahun 2016, kinerja khususnya kinerja penelitian UNRAM telah masuk pada klaster mandiri pada urutan ke-75% teratas dari perguruan tinggi yang sama memiliki klaster mandiri. Namun, pada tahun 2019 telah meningkat, yaitu pada urutan ke-50% teratas. Kini, kami dalam jajaran LPPM akan tetap mempertahankan klaster mandiri tersebut melalui berbagai macam kegiatan, terutama adalah bagaimana caranya kita memberikan kesempatan pada dosen-dosen Universitas Mataram untuk dapat membuat proposal yang berkualitas. Oleh karenanya, maka kegiatan yang mendukung kinerja tersebut melalui klinik pembuatan proposal, klinik agar supaya penelitian tersebut menghasilkan luaran-luaran yang berarti, juga dilaksanakan klinik pembuatan luaran-luaran penelitian.
Pada prinsipnya bahwa pengabdian itu adalah untuk meningkatkan kesejahteraan pada masyarakat. Pengabdian itu bisa dilakukan oleh mahasiswa maupun dosen. Nah, saat ini mahasiswa turun ke lapangan melalui KKN tematik dan pemberdayaan. Yang saat ini jumlah peserta KKN itu adalah sebanyak 3.000 mahasiswa tersebar di 300 desa. Adapun jenis-jenis KKN saat ini yaitu KKN tematik atau pengabdian, antara KKN wisata, KKN zero waste, KKN adminduk, KKN kelompok usaha bersama atau disebut dengan KUB, KKN BNPB, dan KKN BKKBN.
Bahwa sejak tahun 2018 aktifnya sentra ini, kami sudah mengerjakan beberapa kegiatan, antara lain membantu dosen-dosen yang mendapat skim penelitian dasar, yang salah satu luarannya adalah menghasilkan buku. Nah, sehingga pada tahun 2018 Universitas Mataram sudah memiliki sekitar 125 lebih hak cipta dari berbagai buku yang dihasilkan oleh dosen. Kemudian yang kedua, kami juga membantu dosen yang mendapat skim terapan yang luarannya berupa teknologi tepat guna yang kami daftarkan untuk mendapatkan paten, sehingga pengelolaan sentra intelektual ini keberadaannya menjadi sangat penting di Universitas Mataram.
Sebagai pusat unggulan biosains bioteknologi yang sebelumnya juga di laboratorium ini telah berkembang dengan pesat kegiatan imunobiologi, waktu itu dipimpin oleh Profesor Dr. Mulyanto, yang telah berhasil mengembangkan berbagai macam antibodi monoklonal dan bahkan sudah sempat dipasarkan ke berbagai belahan dunia. Pusat unggulan biosains teknologi yang sebetulnya baru lahir sejak tahun 2017 akhir, bahkan di awal 2018, yang kemudian memusatkan perhatiannya pada pemanfaatan makroalga yang dalam bahasa sehari-hari kita sebut sebagai rumput laut untuk berbagai macam manfaat dan kepentingan, baik dalam bidang pertanian, dalam bidang kesehatan, dalam bidang pangan, dan sebagainya. Karena dapat dikembangkan menjadi bahan baku berbagai macam kepentingan, bahan baku obat, bahan baku pangan, dan bahan baku industri dan sebagainya, terutama industri farmasi. Oleh karena itu, maka alga ini memiliki nilai ekonomi yang tinggi.
Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Ali, Ketua Lembaga Penelitian dan Pengabdian kepada Masyarakat Universitas Mataram, atau yang kita kenal sebagai LPPM UNRAM. Adapun tupoksi LPPM Universitas Mataram adalah mengawal terwujudnya visi Universitas Mataram sebagai lembaga pendidikan berbasis riset dan berdaya saing internasional. Untuk mewujudkan visi tersebut, LPPM UNRAM memiliki koordinator di bidang penelitian dan koordinator di bidang pengabdian. Di bidang penelitian, UNRAM memiliki beberapa pusat penelitian, diantaranya pusat penelitian agribisnis, pusat penelitian perencanaan wilayah dan pedesaan, pusat penelitian pengembangan regional, pusat penelitian lingkungan hidup, dan pusat penelitian gender dan anak, dan beberapa yang lain. Untuk mendukung pusat-pusat penelitian tersebut, UNRAM juga memiliki beberapa pusat unggulan ITE, diantaranya pusat unggulan gaharu, pusat unggulan geomagnetik, pusat unggulan ternak Indonesia besar, dan pusat unggulan imunobioscience serta bioteknologi. Di bidang pengabdian, UNRAM memiliki beberapa pusat layanan seperti pusat layanan hak cipta, 2 pelayanan untuk KKN, 3 pusat inkubator, dan beberapa yang lain. Untuk mewujudkan visi UNRAM tersebut, LPPM akan menggerakkan semua komponen sivitas akademika Universitas Mataram untuk mewujudkan riset yang berdaya saing internasional dan melakukan pengabdian yang bermanfaat untuk masyarakat sekitar.
LPPM Universitas Mataram pada tahun 2019 berdasarkan Surat Nomor B/990/E3/RA 2019 dari Ristek Dikti tentang peringkat perguruan tinggi berbasis kinerja pengabdian kepada masyarakat, maka LPPM Universitas Mataram berada pada klaster sangat bagus, yaitu di urutan nomor 5 di atas ITB maupun UNUN. Sedangkan di bidang penelitian berdasarkan surat nomor B/850/E2RS04/2019, LPPM UNRAM termasuk klaster mandiri, berada di urutan 24 dari 1977 perguruan tinggi yang berada di Indonesia. di atas dihasilkan dari penilaian kinerja kelembagaan untuk bidang penelitian dan pengabdian kepada masyarakat yang berasal dari komponen. 1. Dana manajemen meliputi kegiatan penjaminan mutu dan sumber daya manusia, rekrutmen penilaian internal, seleksi usulan kegiatan, monet internal, tindak lanjut hasil penelitian, kegiatan penghargaan. Yang kedua, berasal dari sumber dana internal perguruan tinggi. Yang ketiga, bidang unggulan. Dan yang keempat, luaran penelitian yang meliputi publikasi ilmiah, keynote speaker dalam pertemuan ilmiah, pemakalah dalam pertemuan ilmiah, serta hak kekayaan intelektual dan luaran lainnya. Yang terakhir adalah hilirisasi hasil penelitian. Untuk mempertahankan dan meningkatkan peringkat di atas, maka diperlukan adanya peningkatan kinerja kelembagaan dari semua pihak terkait dengan penilaian kelembagaan di bidang penelitian maupun di bidang PPM.
Alhamdulillah, sejak tahun 2016, kinerja khususnya kinerja penelitian UNRAM telah masuk pada klaster mandiri pada urutan ke-75% teratas dari perguruan tinggi yang sama memiliki klaster mandiri. Namun pada tahun 2019 telah meningkat, yaitu pada urutan ke-50% teratas. Kini kami dalam jajaran LPPM akan tetap mempertahankan klaster mandiri tersebut melalui berbagai macam kegiatan, terutama adalah bagaimana caranya kita memberikan kesempatan pada dosen-dosen Universitas Mataram untuk dapat membuat proposal yang berkualitas. Oleh karenanya, maka kegiatan yang mendukung kinerja tersebut melalui klinik pembuatan proposal, klinik agar supaya penelitian tersebut menghasilkan luaran-luaran yang berarti, juga dilaksanakan klinik pembuatan luaran-luaran penelitian.
Pada prinsipnya bahwa pengabdian itu adalah untuk meningkatkan kesejahteraan pada masyarakat. Pengabdian itu bisa dilakukan oleh mahasiswa maupun dosen. Nah, saat ini mahasiswa turun ke lapangan melalui KKN tematik dan pemberdayaan. Yang saat ini jumlah peserta KKN itu adalah sebanyak 3.000 mahasiswa tersebar di 300 desa. Adapun jenis-jenis KKN saat ini yaitu KKN tematik atau pengabdian, antaranya KKN wisata, KKN zero waste, KKN Adbinduk, KKN kelompok usaha bersama atau disebut dengan KUB, KKN BNPB, dan KKN BKKBN.
Bahwa sejak tahun 2018 aktifnya sentra ini, kami sudah mengerjakan beberapa kegiatan, antara lain membantu dosen-dosen yang mendapat skim penelitian dasar, yang salah satu luarannya adalah menghasilkan buku. Nah, sehingga pada tahun 2018 Universitas Mataram sudah memiliki sekitar 125 lebih hak cipta dari berbagai buku yang dihasilkan oleh dosen. Kemudian yang kedua, kami juga membantu dosen yang mendapat skim terapan yang luarannya berupa teknologi tepat guna yang kami daftarkan untuk mendapatkan paten, sehingga pengelolaan sentra kekayaan intelektual ini keberadaannya menjadi sangat penting di Universitas Mataram.
Sebagai pusat unggulan biosains teknologi yang sebelumnya juga di laboratorium ini telah berkembang dengan pesat kegiatan imunobiologi, waktu itu dipimpin oleh Profesor Dr. Mulyanto yang telah berhasil mengembangkan berbagai macam antibodi monoklonal dan bahkan sempat dipasarkan ke berbagai belahan dunia. Pusat unggulan biosains teknologi yang sebetulnya baru lahir sejak tahun 2017 akhir, bahkan di awal 2018, yang kemudian memusatkan penelitiannya pada pemanfaatan makroalga yang dalam bahasa sehari-hari kita sebut sebagai rumput laut untuk berbagai macam manfaat dan kepentingan, baik dalam bidang pertanian, dalam bidang kesehatan, dalam bidang pangan, dan sebagainya. Karena dapat dikembangkan menjadi bahan baku berbagai macam kepentingan, bahan baku obat, bahan baku pangan, dan bahan baku industri dan sebagainya, terutama industri farmasi. Oleh karena itu, maka alga ini memiliki nilai ekonomi yang tinggi.
Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Ali, Ketua Lembaga Penelitian dan Pengabdian kepada Masyarakat Universitas Mataram, atau yang kita kenal sebagai LPPM UNRAM. Adapun tupoksi LPPM Universitas Mataram adalah mengawal terwujudnya visi Universitas Mataram sebagai lembaga pendidikan berbasis riset dan berdaya saing internasional. Untuk mewujudkan visi tersebut, LPPM UNRAM memiliki koordinator di bidang penelitian dan koordinator di bidang pengabdian. Di bidang penelitian, UNRAM memiliki beberapa pusat penelitian, diantaranya pusat penelitian agribisnis, pusat penelitian perencanaan wilayah dan pedesaan, pusat penelitian pengembangan regional, pusat penelitian lingkungan hidup, dan pusat penelitian gender dan anak, dan beberapa yang lain. Untuk mendukung pusat-pusat penelitian tersebut, UNRAM juga memiliki beberapa